Welcome to the ultimate one-shot masterclass for the AWS CCP exam. We had traveled through all the 13 modules from the basics of what is a cloud to a high-level strategy of a well-architected framework. In this video, we are condensing months of study into one focused session designed to get you exam ready and career certified. This PDF is a whole AWS CCP exam syllabus and we are covering it all with no stones unturned from module 1 to module 13. If you are ready to crack the AWS CCP exam, hit that subscribe button, grab your coffee, and let's dive into module 1. Welcome to AWS Cloud Practitioner tutorial. Before we dive into the tech, we need to understand why AWS exists. Rewind to the early 2000s. Amazon.com was rapidly growing from a bookstore into a global e-commerce giant. To keep up, their IT teams were constantly scrambling, developing more servers, more storage, and more compute just to keep the site alive. To solve this, they built standardized, scalable tools to make their own infrastructure more efficient. In 2003, they realized these tools were a product in themselves. By 2004, AWS launched first public service SQS. By 2006, S3 and EC2 followed. What started as an internal solution for Amazon's growing pains turned into the world's leading cloud platform. So what exactly is the cloud? Here is the gold standard definition you need for the CCP exam. Cloud computing is the on-demand delivery of IT resources over the internet with pay-as-you-go pricing. Let's break that down into three more pillars. First will be on-demand delivery. Second will be over the internet, and third will be pay as you go. We talk about on-demand delivery. You use resources exactly when you need them. If you suddenly need 2000 terabytes of storage, you don't call a vendor and wait weeks for hardware. You open an AWS account, upload to S3, and you are live. When you are done, delete the files and the billing stops instantly. Second, over the time, you don't need to be near a data center. Whenever you are at home or in office or traveling, all you need is a browser and internet connection to manage your entire global infrastructure. Third, pay-as-you-go pricing. There are no long-term contracts. If you don't need a server, you shut it down and stop paying. It's a utility model like paying for electricity. Historically, if a business wanted to run an application, they had to build or rent a physical data center, building full of servers, cooling systems, and security teams. This is expensive and time consuming. With AWS, you are using their world-class data centers. This shifts the burden of heavy lifting like hardware maintenance and power redundancy onto Amazon. This allows your team to stop worrying about cables and cooling and start focusing on what actually matters. That is innovation and your customers. To reiterate, on-demand delivery over the internet with pay-as-you-go pricing. Keep that definition front and center as we move through the rest of this course. Let's discuss about cloud deployment types. You can deploy cloud resources in multiple ways, like on cloud, on premises, and hybrid. Each type offers unique benefits and considerations. Exploring these options can help you make informed decisions about your cloud strategy. And if you see this, first is cloud-based deployment. In cloud-based deployment model, you have flexibility to migrate your existing resources to the cloud, design and build new applications within the cloud environment, or use a combination of both. For instance, a company might migrate data resources to the cloud, then develop an application comprised of virtual servers, databases, and networking components entirely hosted on the cloud. Second is on-premise deployments. Deploying resources on-premise using virtualization and resource management tools does not provide many of the benefits of cloud. However, it is sometimes sought for its ability to provide dedicated resources and low latency. In most cases, this deployment model is the same as legacy IT infrastructure while using application management and virtualization technologies to try increasing resource utilization. Third is hybrid deployment. In the hybrid deployment, cloud-based resources and on-premise infrastructure work together. This approach is ideal for situations where legacy applications must remain on-premises due to maintenance preferences or regulatory requirements. For instance, a cloud might choose to retain certain regulated legacy applications on premises while using cloud services for advanced data processing and analytics. Multi-cloud deployments can also be considered as a hybrid deployments. Now that we know what the cloud is, let's talk why it's a game changer. AWS defines 6 primary benefits of cloud computing that every practitioner needs to know. Let's break them down. First one is trade fixed expense for variance expense. In a traditional on-premise setup, you have fixed expenses, right? You are dropping hundreds of thousands, maybe millions upfront on hardware, physical space, and power before you even send your first email, right? With AWS, you trade that for variable expenses. You don't need a huge investment to start. You start small, pay only for what you use, and use built-in tools to track every cent. It's a difference between buying the whole power plant versus just paying the monthly electric bill. Second is benefit from massive economies of scale. This is a simple volume play. Because AWS has millions of customers, they buy hardware, servers, hard drives, cables at a scale no single company could match. This allows them to get massive discounts, which they then pass back to you in the form of lower service cost. You get bulk pricing even if you are a one-person startup. Third is stop guessing the capacity. In the old world, you have to predict the future. If you bought hardware for 10 million users but only got 500,000, you are stuck with expensive, dusty zombie servers. On the flip side, if you underestimated your growth, your site would crash while you waited weeks for the new parts. In AWS, you stop guessing. Scaling take minutes, not months. You provision what you need now and use scaling tools to grow or shrink automatically based on the real-time demand. Fourth is increase speed and agility. This is where innovation happens. In the cloud, a developer can spin up a complete test environment in seconds. Want to try a new idea? Run the experiment. If it fails, just hit delete and stop paying. This agility means you spend less time waiting for hardware and more time building features your customers actually want. If they stop spending money running and maintaining the data centers. Running a data center is undifferentiated heavy lifting. Hacking servers, stacking cables, managing cooling, and hiring security guards doesn't make your product better. It just keep the lights on. By using AWS, you let them handle the physical infrastructure. This frees up your team to focus exclusively on your business and your customers. Sixth is go global in minutes. Finally, the world is your playground. If you are a company in the US wanting to expand to India, you don't need to fly a team over to build a data center. You simply deploy your application to an AWS region in India with the few clicks. What used to take years of legal and physical preparation now happens in minutes. These are the 6 pillars. As we move deeper into the AWS services, you will see exactly how these benefits will come to life. We have talked about going global in minutes, but there's a massive technical advantage to AWS global reach that we have not touched on yet. That is high availability. To understand this, let's look at a growing food business. Imagine you run a popular cloud kitchen. Orders are pouring in, the chefs are moving fast, but then a disaster happens. A main water pipeline bursts right over your electrical panel. The power shuts out, the oven shut down, and the entire kitchen goes dark. You can't accept orders. You can't cook. You are out of business. Luckily, your business is a franchisee. You have another kitchen location just a few kilometers away in a different neighborhood. Your digital orders simply reroute to the second kitchen. Your customers still get their meals on time, and your business keeps generating revenue while the first location gets repaired. This is the essence of being highly available. In the IT world, having just one giant data center is like having only one kitchen for an entire city. If the local power grid fails, your whole brand goes dark. To prevent this, we design for two things: First is high availability. It is for ensuring your app remains accessible with minimal downtime. If one kitchen fails, another kicks in immediately. Second is fault tolerance. This goes a step further. It's designing your system to stay operational even if multiple component fails, like having a backup generator, a secondary water lines, or extra staff already on standby. It's about ensuring no single point of failure can take you down. AWS built this resilience into its physical DNA using a specific hierarchy. First, we have regions of these as major cities, places like Mumbai, Tokyo, or London. Each region is a separate geographic area designed to be close to your customers to reduce the lag. But inside each region, the magic happens in availability zones. Each region has 3 or more availability zones. An availability zone is like a cluster of independent data centers with its own redundant power and networking. Crucially, availability zones are physically separated by miles. If a flood or a local outage hits one availability zone, the others stay dry and fully operational. Now you might be thinking, but if a massive natural disaster hits the entire city of Mumbai? Great question. That's why professional AWS architectures often run across multiple regions. And this we had seen this in recent Iraq, Israel, and US wars. Due to multi-region deployments, most of the companies saved their data from a big disaster of the war. If a once in a current century storm hits Mumbai region, your traffic can automatically fail over to the Hyderabad location. By spreading your digital kitchens across multiple availability zones and regions, your business becomes virtually disaster proof. Whether it's a burst pipe in the kitchen or a regional power outage, AWS infrastructure ensures your application stays up and your customers stay feed. Now let's discuss about another important concept, that is AWS shared responsibility model. When you move your business to AWS, you have to ask critical question: who is responsible for security? Is it the customer or AWS? The answer is both. This is what we call as the AWS shared responsibility model. Think of it like renting a professional commercial kitchen for your food business. The landlord provides the building, the gas lines, and the heavy duty locks on the front door. They are responsible for the security of the kitchen. But if you leave the back door propped open while taking out the trash, or if you let the stranger walk in, touch the food, that's on you, right? You are responsible for security in the kitchen. The AWS handles the foundation. They are responsible for security of the cloud, and this includes the physical layer, the network layer, and the hypervisor. Hypervisor is a software that allows multiple customers to share one physical server while keeping their data completely separate. And the physical server is the actual data centers, and the network layer ensures that the pipes that carry data are secure and isolated. Just like a landlord ensures the walls are strong and the roof doesn't leak, AWS ensures the global infrastructure is bulletproof. Now let's talk about your side. You are 100% responsible for security in the cloud, whether it's an operating system or application or data. AWS gives you the locks like encryption and access control list, but you have to be the one to turn the key, right? One of the best tools AWS gives you is encryption. Think of this like putting your secret recipe in a high-tech safe inside the kitchen. Even if someone somehow bypassed the landlord security and your propped open door, all they would find is a locked box they can't read. Encryption ensures that even if a mistake happens, your most sensitive data remains unreadable to anyone without your specific key. To wrap up, just remember this simple phrase for your exam, that AWS is responsible for security of the cloud and you are responsible for security in the cloud. Both sides do their part. You create an environment that is more secure than almost any private data center could ever be. That's pretty much about module 1. We will be talking about compute in the cloud. Before deep diving, let's understand what happens if your phone tries to edit a 4K video. It gets hot, it lags, and it might crash. That's because your phone has limited resources. Even sometimes if you try to play some high graphics game, had you noticed that your phone starts lagging? This all happens because of limited resources, and these resources are nothing but compute. So in general, compute is the engine of a computer. It is the actual power that runs your apps, calculates your physics in games, and processes every click you make. Now imagine you want to play GTA 5. Can you play that on a laptop which is 10 years old? No way. You need to buy a new laptop or a new machine to play it. Now, even if you bought this new laptop, you want to play GTA 5 as well as Fortnite, as well as some other games. You have constraints like storage limit, CPU limit, graphic card limit, RAM limit. This will simply stop you from expanding your library. This is where cloud compute comes into picture. You rent a powerful cloud computer from a company. You don't physically touch it. You log into it over the internet. This cloud-based rented computer is known as EC2. The full form of EC2 is Elastic Cloud Compute. Elastic is added because you can literally think that as a rubber band. You can expand your compute as much as you can. You can even play million time heavy game than GTA 5, and parallelly you can even stream or play another games up to infinite. This whole concept is known as EC2. If we talk about the definition, Amazon Elastic Cloud Compute is a foundational AWS service providing secure, resizable virtual servers in the cloud. It enables on-demand computing capacity, allowing users to launch, configure, and terminate servers instantly without buying physical hardware. EC2 supports diverse operating systems and app workloads, offering elasticity to scale up or down as needed. Before EC2, there were many challenges of on-premise resources, like you were responsible for designing your company's infrastructure to support new websites. You must purchase hardware upfront, wait for delivery, and handle installation and configuration. This process was very time consuming, costly, and inflexible because you are logged into specific capacity that might not align with changing demands. In contrast with Amazon EC2, you can quickly launch, scale, and stop instances based on your needs without the delays and upfront cost associated with the traditional on-premise resources. Now that we have learned about EC2, let's peel the onion back and discuss the types of instances. Visualize EC2 instances as different types of coffee machines in your coffee shop. Customers like variety. Not all of them drink the same thing, so we need more than just one type of coffee machine. For example, you will need a high-powered espresso machine for those who want espresso shots. You will also need a classic drip coffee machine for customers who want the sauce, and maybe a cold brew machine for those who want their caffeine chilled. Therefore, if we want our business to operate as efficiently as possible, it's important to use the right coffee machine for each order. This is similar to deploying EC2 instances. There are different types of instances that serve different purposes in your AWS environment. Instance types are grouped under the instance families, which offer varying combination of CPU, memory, storage, and networking capacity. This gives you the flexibility to optimize for certain types of tasks by choosing instances specific to your particular workloads. The different instances families are general purpose, compute optimized, memory optimized, asset-related computing, and storage optimized. The general purpose instances provide a good balance of compute, memory, and networking resources. They can be used for lots of diverse workloads like web services or code repositories. They are also a good starting point if you don't know how your workload will perform ahead of time. Compute optimized instances are ideal for compute intensive tasks. like gaming servers, high performance computing, machine learning tasks, even scientific modeling. Memory optimized instances are good for memory intensive tasks. They deliver fast performance for workloads that process large data sets in memory. Accelerated computing instances are good for floating point number calculations, graphic processings, or data pattern matching. This is because they use hardware accelerators. These are coprocessors that perform functions more efficiently than is possible in software running on CPUs. And finally, the storage optimized instances are ideal for workloads that require high performance for locally stored data. After you have decided on an instance type, the next part is to choose the right instance size. I urge you to keep not just performance in mind but also cost. Here, bigger instances give you more CPU, memory, and storage, but also more cost. So it's important to find a balance that fits your needs and budget. This ensures that you choose the right instance size to get the best performance but without paying for resources you don't really need. The best part is that you don't have to use a specific instance type or size forever. You might find that one you initially choose doesn't offer the performance you need. That's perfectly fine. You can change it. The cloud gives you that ability to pivot very quickly, so take advantage of it. You might be wondering, how do I actually interact with this EC2 and other services? And the answer is API. In AWS, everything is an API call. An API is an application programming interface that defines predefined ways for you to interact with AWS services. And you can invoke or call these APIs to provision, configure, and manage your resources. There are three main ways you could call AWS APIs: using AWS Management Console, using CLI, or using SDK. First, let's talk about console, which is browser-based. Using the console, you can manage your resources visually and in a way that is easy to digest. This is great for getting started and building out your knowledge of the services. It is also helpful for setting up test environments, viewing AWS builds, monitoring resources, and managing non-technical tasks. The console is most likely the first place you will go when you are learning about AWS. Next up, you can use the AWS CLI to invoke AWS APIs using a terminal. This is different than the visual navigation style of the console because it allows you to interact with AWS services through text-based input called commands. This makes automation through scripting possible. Another way to interact with AWS is through AWS SDK. AWS SDK makes it possible for you to interact with AWS resources through various programming languages like Python, for example. Now we are going to walk through the process of creating an EC2 instance for a web server using the Amazon console. We will go over some key configurations along the way, so let's get started. First thing we want to do is go to EC2 console. And first thing we have to choose is the name. We have to choose our instance name so we can find it later. Next thing we are gonna do is choose the Amazon machine image or AMI. And AMI is the template of the operating system and the built-in application that it's going to come with. You can customize this, but for right now, you are going to go with the default, the Amazon Linux AMI. Now this Amazon Linux AMI is perfect for general use web servers. The next thing we have to decide on is the instance type. This refers to how much computing power our web server is going to have. In this case, we are gonna choose just the basic T2.micro. We will go over some of the details that make up this a little bit later, but for right now this is going to be fine. It's in the free tier, sounds good to me. The next thing we choose is the key pair, and this is related to how we are logging into a EC2 instance. A key pair refers to a pair of keys, specifically a public key which is going to be injected into the EC2 instance and a private key which we will keep. We can create that key pair right here, and I am gonna go ahead and choose a key that we have already established. The next step is choosing the network settings. We are going to have a lot of fun going through all these details a little bit later. But for right now, suffice it to say, we are going to allow HTTP traffic from internet. This is going to be a web server after all, so that's all we have to do. The next option we have to choose is the storage options for our EC2 instance. In this case, we are going to give it 8 gigabytes of disk space using the GP3 EBS volume or Elastic Block Storage volume. We will go over what that means a little bit later, but this means it's going to have a plenty of space for web serving. And speaking of web serving, we do have to make one more change, so it's actually is a web browser. When we picked the AMI, we picked a very generic AMI. This doesn't have the web server activated at launch. In order to do that, we are going to go into advanced details, specifically down to the user data section. What the user data section allows us to do is to paste in a script such as this one, which will go ahead and install and activate NGINX web server, and we will see what we get. As soon as the instance launches, we can go to its console and see some of the details about that EC2 instance. Now that our instance is running, I am going to copy its public IP address. I am going to open a new browser and let's go. And there you have it. Your very own EC2 instance running a basic web server. Congratulations, that's the basic thing for setting up EC2 instances. And we are gonna get into more details about the nuances later in the course. We talked about Amazon EC2 instance type, but you are all probably wondering how much is this gonna cost me? Well, don't fret. For EC2, we have multiple billing options available. The most widely used option is on demand. This means you only pay for duration that your instance runs. This can be per hour, per second, depending on the instance type and the operating system you choose. Even better, no long-term commitments or upfront payments are needed. Most customers typically use this service when they get started. This makes it possible to spin up servers, play around, test out workloads. It's all self-service. This helps you figure out a baseline for your average usage. Using that average, you can start to explore other pricing options like the next one, which is Savings Plan. Savings Plan offer lower EC2 prices for a commitment to a consistent amount of usage. This is measured in dollars per hour for a 1 year or 3 year term. This can provide savings of up to 72%, which is significant. In fact, it can lower prices on your EC2 usage regardless of instance family, size, operating system, tenancy, or AWS region. Additionally, it applies to AWS Fargate and AWS Lambda usage. Those are serverless compute options that we will cover later. Another option is reserved instances. These are well suited for steady state workloads or ones with predictable usage. They offer you up to 75% discount compared to on-demand pricing. You qualify for a discount after you commit to a 1 year or 3 year term plan. There are also 3 payment options, all upfront, where you pay for them in full when you commit, partial upfront, where you pay for a portion when you commit, and no upfront, where you don't pay anything at the beginning. The next option is spot instances. These make it possible to request spare EC2 capacity for up to 90% off the on-demand price. The catch here is that AWS can reclaim the instance at any time. However, you do receive a 2-minute warning, so you can save your progress and you can always resume later if needed. So make sure your workloads can tolerate being interrupted if you choose spot instances. And finally, we have dedicated host. These are actual physical servers that customers can reserve for exclusive use. No other customers' workloads can share the server. This isolation use case is ideal for security sensitive or licensing specific workloads like Windows or SQL servers. This is because you have control over instance placement and resource allocation. This helps with meeting certain compliance and regulatory needs. With a variety of EC2 pricing options available, you can choose the most cost-effective solution based on your usage patterns. This helps you to balance flexibility, cost savings, and specific workload needs. Let's now discuss about scalability. Scalability refers to the ability of a system to handle an increased load by adding resources. You can scale up by adding more power to existing machines, or you can scale out by adding more machines. Scalability focuses on a long-term capacity planning to make sure that the system can grow and accommodate more users or workloads as needed. We solved the scaling problem with Amazon EC2 auto scaling, but what if we have got a bit of traffic problem? This is where Elastic Load Balancer comes to rescue. Elastic Load Balancing automatically distributes incoming application traffic across multiple resources such as EC2 instances to optimize performance and reliability. A load balancer serves as a single point of contact for all incoming web traffics to an auto-scaling group. As the number of EC2 instances fluctuates in response to traffic demands, incoming requests are first directed to load balancer. From there, the traffic is distributed evenly across the available instances. Although Elastic Load Balancer and EC2 auto-scaling are distinct services, they work in tandem to enhance application performance and ensure high availability. Together, they enable applications running on EC2 to scale effectively while maintaining consistent performance. To optimize traffic distribution, ELB uses several routing methods like round robin, least connections, IP hash, and least response time. These routing strategies work together for efficient traffic management and optimal application performance. If we talk about round robin distributes traffic evenly across all the servers in a cyclic manner. The least connection routes the traffic to the servers with the fewest active connections, maintaining a balanced load. IP hash uses a client's IP address to consistently route traffic to the same server, and least response time directs traffic to the server with the fastest response time, minimizing the latency. Now let's discuss about monolithic and microservices architecture. Monolithic applications are the applications that consist of multiple components that work together to transmit data, fulfill requests, and keep the applications running smoothly. In a traditional approach to application architecture, the components such as database logic, web application servers, user interfaces, and business logic are tightly coupled. This means that if one component fails, it can cause the failure of other components, potentially bringing down the entire application. And microservice architecture is to improve application availability and resilience. You can adopt a microservice architecture. In this approach, the application components are loosely coupled, meaning if one component fails, the other continue to function normally. The communication between components remain intact, and the failure of a single component does not impact the entire system. This design promotes greater flexibility and reliability in the application. Now, the last topic for this video I want to touch on is how we can support scalable and reliable cloud communication. For this, Amazon Event Bridge, Amazon SNS, and Amazon SQS are AWS services that help different parts of an application communicate effectively in the cloud. These services support building event-driven and message-based systems Together, they help create scalable, reliable applications that can handle high traffic and can enhance communication between components. If we talk about Event Bridge is a serverless service that helps connect different parts of an application using events, helping to build scalable event-driven systems. With Event Bridge, you route events from sources like custom apps, AWS services, and third-party software to other applications. Event Bridge simplifies the process of receiving, filtering, transforming, and delivering events so you can quickly build reliable applications. For example, you ordered something on Zomato. First event will happen is payment application. Once that is done, the restaurant receive a second event notification to start preparing the meal. And then the inventory system check if the ingredients for the order are available. And at last, a delivery driver is notified to pick up and deliver the meal. This is how Event Bridge can route events like order placed or payment completed to relevant services like payment, restaurant, inventory, and delivery. It can handle high volumes of events during peak times, making sure each service works independently. Next, if we talk about Amazon SQS, it is a messaging queue service that facilitates reliable communication between software components. It can send, store, and receive messages at any scale, making sure messages are not lost and that other services don't need to be available for processing. In Amazon SQS, an application places messages into a queue and a user or service retrieves the message, processes it, and then removes it from the queue. Third and last is Amazon SNS. SNS is a subscribe service that publishers use to send messages to subscribers through SNS topics. In SNS, subscribers can include web servers, email address, Lambda functions, and various other endpoints. You will learn about Lambda in more details later. With that said, we had completed the module 2. Hope you had enjoyed it. Welcome back. Module 3, Exploring Compute Services. At this point, we have learned how to use Amazon EC2 to provision compute resources in the cloud, and that's great. EC2 is one of the foundational services in AWS, and understanding how to use it is key. To quickly recap, EC2 instances are virtual machines that you can provision on AWS. EC2 is great for all sort of use cases, from running basic web servers to high-performance computing workloads and everything in between. EC2 offers a high degree of control when it comes to your instances, but it also requires that you manage that fleet of instances over time. EC2 is an unmanaged service, meaning you have control over tasks like patching, scaling, and managing the operating system, while AWS manages the underlying infrastructure. Think back to the shared responsibility model where AWS is responsible for the security of the cloud and you are responsible for security in the cloud. On the other hand, AWS also offers managed services. Managed services shift more operational responsibility to AWS, so you can focus on building your application and less on managing the infrastructure. AWS services span a range from unmanaged to managed, offering you varying degrees of control and convenience. Some services like EC2 allow you to fine-tune everything. You are in charge of all configurations and management. And there are managed services. Some examples of managed services that you have already learned are Elastic Load Balancer, SNS, and SQS. For managed services, you configure the service to meet your requirements and then AWS ensure it runs smoothly over time with no server management required on your part. This idea of not managing any underlying infrastructure led to the rise of serverless computing. Serverless means that you can't actually see or access the underlying infrastructure or instances that are hosting your application. Instead, all the management of underlying environment from provisioning, scaling, high availability and maintenance perspective are handled for you. All you need to do is focus on your application. With a new understanding of terms like unmanaged, managed and serverless, we are going to explore some of the other compute services that AWS has to offer. There are many services available built for different use cases, and we will be covering some of these in the upcoming lessons. AWS offers all these different compute services to give you options that cater to various workloads, requirements, and level of management. The key is to recognize what your specific application needs are and choose a service that provides the right balance of customization and ease of use. Okay, time to dive into my favorite managed service, that is AWS Lambda. Lambda is the serverless compute service. It's also known as function as a service. With Lambda, you don't need to think about servers. You create a Lambda function, put your code in there, configure a trigger, and your function runs in response to the trigger. This managed environment is automatically scalable and highly available. This means whether you get a single trigger or thousands, Lambda will scale up or down to meet the demand. Even better, AWS take care of all the patching, updates, and security. You simply focus on your code, and with that code, just be aware that the maximum duration of a Lambda function is 15 minutes. But if you cannot split your code into 15-minute segments, Lambda might not be a good fit for you. Lambda is great for quick, event-driven processes. For example, handling website requests, processing batches of data, and generating expense reports. Lambda supports several languages by default through the use of runtimes, languages like Java, Python, and Node.js. However, you can build your own custom runtime. A runtime provides a language-specific environment that relays invocation events, context information, and responses between Lambda and the function. One last thing to mention is that Lambda integrates with other AWS services quite easily. This means you can build out your fully fledged app using a plethora of AWS services and still not have to worry about spinning servers up and down. You just have to worry about putting all these scrap pieces into your database. So far, we have talked about EC2 and Lambda, and there's another compute service we have not talked about. Let's talk about containers. Imagine you are a developer trying to deploy an application that's worked perfectly on your computer but fails everywhere else. That's frustrating, right? You might even have heard developers trying to debug this issue and saying to each other, "It works on my machine." Containers solve this portability problem by providing a consistent environment that can be replicated anywhere. That's what containers do. They package everything your application needs to run: code, runtime, dependencies, configurations, into a single portable unit. This creates a consistent environment, isolating your application from the underlying system and making it convenient to deploy and scale your application anywhere. Containers also provide benefits like faster start times and improved resource efficiency. Now that you understood what containers are, let's talk about hosting them on AWS. You can manage containers on your own, where you place containers on top of clusters of EC2 instances, but it's a lot of work. You'd have to deal with monitoring the health of the containers, starting and stopping them when needed, updating them, and managing the networking from them, and more. You can manage it, of course, but it would be complicated and easy to mess up. That's where container orchestration services comes in. Container orchestration services manage the life cycle of containers, including starting, stopping, and running them across the cluster. These orchestration services automatically scale containers out when traffic increases and scale back in when things calm down. This way, your application can handle spikes in demand without breaking a sweat. They also handle recovery from failure, monitoring, and updates, saving you tons of time and effort. On AWS, we have two main container orchestration options, ECS and Amazon EKS. Let's break them down. Amazon ECS stands for Amazon Elastic Container Service. It's ideal if you want something streamlined and integrated, but you can still define your application's container images and resources such as EC2 instance type and load balancer. ECS automatically manages the containers and their infrastructure based on the parameters you set. On the other hand, you have Amazon EKS or Amazon Elastic Kubernetes Service. Kubernetes is an open source platform that automates containerized application deployment, scaling, and management. EKS makes it convenient to run Kubernetes cluster on AWS. It offers a lot of control and flexibility, especially for large scale or hybrid deployments. Now, orchestration services need somewhere to get their customers from. That's where Amazon Elastic Container Registry or Amazon ECR comes in. ECR is the fully managed container registry that stores your container images. You build your containers that have your application and all of its dependencies bundled together. From there, a container orchestration tool can pull the container image and deploy it. So you have got your container image and you have chosen an orchestration service. Now let's focus on where your containers will actually run. AWS offers two main options for this: Amazon EC2 and AWS Fargate. With EC2, you manage the virtual machines that run your containers. With this option, you have full control, but you need to manage the underlying infrastructure. On the other hand, Fargate is serverless and offers efficiency and convenience. With Fargate, AWS manages the servers and you only need to worry about your containers. No need to manage a fleet for these containers to run on. With AWS, deploying and managing containers is convenient, efficient, and scalable, perfect for keeping your focus on where it matters the most, that is on your application. So far, we have covered compute options like EC2 Lambda and container services like ECS. But wait, there's more. There are many purpose-built services you can use for specific use cases that can help you achieve your goals. Let's take a quick look at some of them. First up is AWS Elastic Beanstalk. This is a service that makes it easier to deploy and manage applications in EC2 instead of building out the needed infrastructure like the network, EC2 instances, scaling, and elastic load balancers by yourself. You can provide your application code and desired configurations to the Elastic Beanstalk service. Elastic Beanstalk then takes that information and builds out your environment for you. Elastic Beanstalk also makes it easy to save environment configurations so they can be deployed again. You won't need to provision and manage all of these pieces separately, and you will still have visibility and control of the underlying resources. Next up, let's talk about AWS Batch, a compute service designed for heavy-duty tasks like processing massive datasets, running simulations, or performing complex calculations. AWS Batch takes care of the infrastructure management for you. You won't need to worry about provisioning servers, scaling resources, or managing infrastructure. AWS Batch handles all of them, allowing you to focus on the important tasks like building your application or running your analysis. The service also scales automatically, distributing tasks across a fleet of compute resources like EC2 instances. Then there's Amazon Lightsail, which simplifies web application hosting by giving you a relatively easy, cost-effective solution for running specific types of applications and websites. It takes care of a lot of the complexity that comes with traditional web application hosting, and it's a great option if you want something quick and easy to manage. Finally, let's talk about one more unique purpose-built AWS service called AWS Outposts. This one is designed for organizations that need a hybrid cloud solution. If you want to leverage the power of AWS while keeping some of your infrastructure on premises, Outpost is the answer. Outpost extends AWS services to your on-premises data center, giving you a consistent experience across both environments. You get to run AWS services locally while still benefiting from cloud computing. This is perfect for meeting specific needs like low latency, data residency, or integration for hybrid deployments. And there you have it. From Elastic Beanstalk to Outpost, each service is designed to handle specific tasks. So remember that as you learn about other services and their use cases. With that said, we had covered Module 3 as well. Welcome back. One of the best part about AWS Global Infrastructure is that you have lots of options when it comes to which AWS region or regions you deploy your resources in. Before we talk about what factors into this business decision, I want to touch on an important security aspect of AWS regions. Each region is isolated from every other region in the sense that no data goes in or out of your environment in that region without you explicitly granting permission for that data to be moved. This is a good thing. Depending on the type of business you are dealing with and where you operate, you might have to adhere to specific compliance regulations that require your data to remain in one geographical area. For example, if you are working with financial information in Frankfurt, local data governance laws state that this financial data cannot leave Germany. The data that is stored in an AWS region is subject to the local laws and statuses of the country where region lives, which is actually our first of 4 considerations when choosing a region: compliance. Before any of the other factors, you first look at your compliance requirements. Do you have a requirement that your data must live in UK boundaries? Then you should choose the London region. This choice is pretty straightforward. None of the other options really matter. Or let's say you must run inside of Chinese borders, well then you should choose one of regions located in China. Most businesses are not governed by such strict regulations. So if you don't have a compliance or regulatory control that dictates your region, then you can look at the other factors. The second factor is proximity. How close you are to your customer base is a major factor. If most of your customers live in Singapore, consider running out of Singapore region. You can certainly run out of Virginia, but the time it takes for the information to be sent or latency between the US and Singapore is always going to be a factor. For number 3, we have feature availability. Sometimes the closest region might not have all the AWS features you want. Here's one of the cool things about AWS. They are constantly innovating on behalf of customers. Every year, AWS releases lots of new features and products specifically to answer customer requests and needs. These features are rolled out to regions over time, so that is also a consideration. Finally, factor number 4 is pricing. Even when the services and features are equal from one region to the next, some locations are more cost-effective to operate in than others. Things like local tax structure and energy cost factors into the equation. AWS have a very transparent, granular pricing that we will continue to discuss in this training. But know that each region has different number of pricings. To wrap up, you have a lot of options in terms of where to deploy your resources. Keep these 4 key factors in mind when choosing a region, that is compliance, proximity, feature availability, and pricing. At this point, you have seen how user proximity, regulatory compliance, service availability, and even pricing can play a factor in selecting an AWS region. When it comes to infrastructure, you also want to plan for long-term stability and less or virtually no downtime for your users. So if your infrastructure has an interruption, you can switch to redundant or backup infrastructure seamlessly. This is called building redundant architectures. One method for redundancy is an architecture that uses multiple availability zones. In a multi-AZ architecture, if an availability zone has an interruption, no worries. Your application will automatically switch to the backup availability zone you have configured. Even better, if you set it up correctly, your customers won't even notice a difference. Additionally, multiple availability zone architectures can assist with quicker disaster recovery, improved business continuity, lower latency, and compliance. As with anything in the world, there are multiple ways to peel an orange. In fact, you can go one step further and deploy your application in multiple AWS regions. So if a whole region experiences an interruption, you can fail over to another one. Some of you might say, wait, bro, multi-region and multi-availability deployments? This sounds like some sort of pinball machine. Well, yeah, it is exactly like a pinball machine, but with a multi-ball bonus. It can be difficult to juggle multiple pinballs initially. They are moving in different directions and you might stress about keeping track of all of them. However, once you come up with a strategy and you get some experience, it gets much easier. Looks like Durandar is so popular in India that people are making memes of it. However, images are loading slowly for some people on the app. Let's fix that by utilizing Amazon CloudFront. CloudFront is a content delivery network and it's designed to serve content as close to users as possible. This content can be images, data, videos, applications, APIs, and in our case, memes. CloudFront uses edge locations, which are part of our worldwide Amazon Global Edge Network. These edge locations are actually separate from regions and are specifically designed to accelerate content delivery. Edge locations host other AWS services like AWS Global Accelerator and Amazon Route 53. Route 53 is a domain name system or DNS that routes end users to internet applications. Essentially, it converts human-readable URLs to machine-readable IP addresses. And don't forget about AWS Outpost. Say you have a need, that need is for speed, more speed than even a region paired with CloudFront can achieve. This is where Outpost comes into handy. As you might recall, Outpost essentially makes it possible for you to run AWS services on premises. Look, keep these multi-deployment concepts and edge services in your brain as you continue to explore AWS global infrastructure. By now, you know that in order to manage AWS resources, you have to interact with AWS APIs. You have learned how to do this using the management console, the CLI, and SDKs. But what happens when you need to create and manage multiple resources, possibly across multiple AWS regions or multiple accounts, and you want to make sure everything is consistent and repeatable? Say you have resources in region A and you want to launch them in region B for high availability. You could set everything up manually by clicking through the console or running commands, remembering all of your configurations as you go along, but that's slow, error-prone, and hard to reproduce. Or you can use automation, and this is where the concept of infrastructure as code or IAC comes in. You can use IAC to define your infrastructure in a file, almost like a blueprint for your AWS architecture. You can then use tools or services to automatically build and configure your resources based on your blueprint specifications. You can deploy the same setup multiple times without variation, and you can track changes to your infrastructure more effectively using source control. AWS CloudFormation is an IAC service that you can use to define a wide variety of AWS resources in a declarative way by creating text-based documents called CloudFormation templates. You can define what resources you want to build without specifying the details of exactly how to build it. CloudFormation parses the template and then provisions all the resources you define, calling the needed AWS APIs in the background to make it all happen. When you deploy the same template in multiple accounts or multiple regions, identical environments are created across them, there's less room for human error because it is totally automated process. So now instead of manually setting up resources in region B to match region A, you can create a CloudFormation template that defines everything your infrastructure needs with a single command. AWS provisions those resources exactly as defined. With that said, we had covered module 4 as well. Imagine building a multi-million-dollar business only to realize you left the front door wide open, or worse, you locked the door but forget to build the walls. In AWS Cloud, there are millions of resources. Without boundaries, your data is just floating in a digital ocean where anyone can swim up to it. Today, we are not just organizing resources, we are building a digital fortress. By the end of this video, you will understand how to isolate your crown jewels while letting your customers in through the VIP entrance. First, you need your own private land. This is the Amazon VPC, or virtual private cloud. Think of it as your private gated community in the middle of massive AWS continent. With Amazon VPC, you can provision an isolated section of the AWS cloud. In this isolated section, you can launch resources in a virtual network that you define. It provides three main benefits: increase security, save time, control environment. It helps increase security because you can secure and monitor connections, screen traffic, and restrict instance access. While it comes to saving time, the convenience of using Amazon VPC means you will spend less time setting up, managing, and validating your virtual network when compared to on-premises network management. And control environment is something where Amazon VPC gives you full control over your resource placement, connectivity, and security. Now you have your own private land, which is VPC, but we don't just throw everything into this one big pile. We make a building full of rooms. These rooms in AWS are known as subnets. A subnet is a section of a VPC in which you can group resources based on security or operational needs. Subnets can be public or private. The public subnet, this is like the lobby of your building. It's where your website lives so customers can see it. Public subnets contain resources that need to be accessible by the public, such as online store website. The private subnet, this is the vault. Your databases and sensitive info live here, completely hidden from the street. Private subnets contain resources that should be accessible only through your private network, such as database that contains customers' personal information and order histories. In a VPC, you can define rules to allow resources in different subnets to communicate with each other. For example, you might have an application that uses Amazon EC2 instances in a public subnet communicating with databases that are located in the private subnet. Okay, but how do people get in? For that, we will be having two categories of people, public and our very own private. In AWS, we call these as Internet Gateway and Virtual Private Gateway. The Internet Gateway is to allow public traffic from Internet to access your VPC. You attach an Internet Gateway to the VPC. The Internet Gateway is a connection between a VPC and the Internet. You can think of an Internet Gateway as being similar to a doorway that customers use to enter the coffee shop. Without an Internet Gateway, no one can access the resources within your VPC. But what if you need a secret entrance for your staff? Think of the internet as a public highway. To stay safe, you need a VPN, a secure encrypted tunnel. The virtual private gateway is a specialized door at the end of that tunnel that only recognizes your encrypted traffic. With the virtual private gateway, you can establish a VPN connection between your VPC and a private network, such as an on-premise data center or internal corporate network. A virtual private gateway allows traffic into the VPC only if it is coming from an approved network. Several of the preceding network components have similar abbreviations and are often confused. These components are core building blocks that we will use in many AWS cloud solutions. Let's simplify this. Amazon Virtual Private Cloud is used to establish boundaries around your AWS resources. A virtual private gateway allows protected internet traffic to enter into the VPC, and a virtual private network encrypts your internet traffic, helping protect it from anyone who might try to intercept or monitor it. Now, as we had built our building, your building doesn't live on an island. You need connections. For AWS, we have 4 ways to connect to AWS Cloud. Those are AWS Client VPN, AWS Site-to-Site VPN, AWS Private Link, and AWS Direct Connect. AWS Client VPN, it is for the remote workforce. It's elastic, meaning if you hire 1,000 people tomorrow, it scales instantly without you buying a single piece of hardware. AWS Client VPN is a networking service you can use to connect your remote workers and on-premise networks to the cloud. It is a fully managed elastic VPN service that automatically scales up or down based on user demand. Because it is a cloud VPN solution, you don't need to install and manage hardware or try to estimate how many remote users to support at one time. The benefits are AWS Client VPN provides advanced authentication, remote access. It is elastic and fully managed. If we talk about use case, it can be used to quickly scale remote worker access. If we talk about AWS site-to-site VPN, this is a permanent secure bridge between your physical office and your VPC. Site-to-site VPN creates a secure connection between your data center or branch offices and your AWS cloud resources. If we talk about benefits, site-to-site VPN provides high availability, secure and private sessions, and accelerates applications. And if we talk about use cases, it can be used for application migration and secure communication between remote locations. Third one is AWS Private Link. This is the secret passage. It lets you connect to other services as if they were inside your own VPC without ever touching the public internet. AWS Private Link is a highly available, scalable technology that you can use to privately connect your VPC to services and resources as if they were in your own VPC. You don't need to use an internet gateway, entity device, public IP address, direct connection, or AWS site-to-site VPN connection to allow communication with AWS services or resources from your private subnets. Instead, you control the specific API endpoints, sites, services, and resources that are reachable from your VPC. The benefits include AWS Private Link helps you secure your traffic and connect with simplified management rules. And if we talk about use case, it is used for connecting your clients in your VPC to resources, other VPCs, and endpoints. Now let's talk about another way to connect, that is AWS Direct Connect. It's like the private express train. If you can't risk the traffic jams of the public internet, Direct Connect provides a physical dedicated fiber line from your building to AWS. It's the ultimate in speed and security. Direct Connect is a service that makes it possible for you to establish a dedicated private connection between your network and VPC in the cloud. If we talk about benefits, AWS Direct Connect reduces network cost and increase amount of bandwidth. There are several different types of gateways you can use to connect your AWS resources. Depending on your needs, you might think about AWS Transit Gateway, Network Address Translation Gateway, or Amazon API Gateway. AWS Transit Gateway is used to connect your Amazon VPC and on-premise networks through a central hub. As your cloud infrastructure expands globally, inter-region peering connects transit gateways together using AWS global infrastructure. The NAT Gateway is a NAT service. You can use a NAT gateway so that instances in a private subnet can connect to services outside your VPC, but external services can't initiate a connection with those instances. You learned about application programming interface earlier. Quick refresher: an API defines how different software systems can interact and communicate with each other. The Amazon API Gateway is an AWS service for creating, publishing, maintaining, monitoring, and securing APIs at any scale. As we had identified services that help you connect your AWS cloud to your clients, data centers, and sites, let's quickly review the 4 types of connectivity options. Those are AWS Direct Connect, AWS Client VPN, AWS Site-to-Site VPN, and AWS Private Link. So Direct Connect is a private, dedicated AWS connection to your data center or office. Client VPN connects your remote workforce to AWS or on premises with a VPN. A site-to-site VPN is an encrypted network connection to your Amazon VPCs, and the AWS Private Link connects your VPC privately to services and resources as though they were in your own VPC. You have built the walls and you had built the gates. But how do you stop a Trojan horse from walking right in? In AWS, you have 2 layers of security guards that never sleep. First one is security group. Think of a security group as a specialized bouncer standing right at the door of your EC2 instance. By default, he denies everyone. You have to give him a guest list or the allow rules list. Security groups are stateful. This is a magic word. This means if a bouncer lets you in, he remembers your face and lets you out automatically. He does not check your ID again on the way out. Second one is Network ACL, which is also known as Network Access Control List. Network Access Control List is different. This is a border patrolling standing at the boundary of your subnet. They check every single person entering and every single person leaving. Network ACLs are stateless. They have no memory. Even if they let you in 5 seconds ago, they will check your ID again before they let you step a foot outside the subnet. They also carry the power to say no. Unlike security groups, network ACLs can have deny rules. You can specifically tell them block that one specific suspicious IP address. With both network ACLs and security groups, you can configure custom rules for traffic in your VPC. As you continue to learn more about AWS security and networking, it is important to understand the differences between them. The following table will help you understand which one to use. You can pause and take the screenshot for this. Do you remember the AWS shared responsibility model? When it comes to securing the subnets and the resources in your VPC with network ACLs and security groups, this is your responsibility. These components make up networking traffic protection and are critical defenses in protecting your application in the cloud. Let's also quickly recap 3 global networking edge services which we learned in previous videos. Those are Route 53, CloudFront, and Global Accelerator. Route 53 is a highly available and scalable cloud DNS service. CloudFront is a CDN service that delivers your content with low latency and high speeds. And Global Accelerators is a service that uses the AWS global network to improve application availability, performance, and security. We have covered the entire anatomy of an AWS network, from the private LAN of VPC to the two-factor guards of security groups and network ACLs. Alright, let's talk about Module 6 storage. AWS storage can feel like a massive alphabet soup. S3, EBS, EFS, it's a lot. But here's the secret. Every single thing you do in the cloud needs place to live. If you pick the wrong one, your app breaks, or even worse, your monthly bill explodes. Today we are striping away the jargon. We are looking at the big 3: block, object, and file. By the end of this video, you will know exactly which one to grab and when. Let's understand block storage. Think of block storage as a raw hard drive you would plug into your computer. It's fast, it's local, and it's dedicated to one machine. Block storage provides persistent low latency block level storage volumes that attach to EC2 instances like physical hard drives. Block storage volumes can be encrypted, backed up via snapshots, and modified while in use without disrupting the instance. AWS offers 2 primary block storage services. First, we have the EC2 Instance Store. This is like a sticky note on your desk. It's right there, it's lightning fast. But the second you leave the office or stop your instance, someone throws the sticky notes in the trash. Use it for buffers or crash data, but never put anything there you are not okay with losing. Definition goes like: EC2 Instance Store is an unmanaged, non-persistent, high-performance block storage directly attached to EC2 instances for temporary data. It is not recommended for applications that require data retention. The benefit includes automatically available storage, cost-effective, and high performance. Then there's Amazon EBS. This is your reliable external SSD. If your instance crashes, your data stays safe on the EBS volume. You can even unplug it and move it to a different instance. They are like saving points in a video game. If you mess something up, you just go back to the last snapshot. Definition goes like: Amazon Elastic Block Store is a managed service that provides persistent block storage volumes for EC2 instances, offering various types for different workloads. It's recommended that you take incremental backups of EBS volumes by creating Amazon EBS snapshots. Now, what's EBS snapshot? EBS snapshots are point-in-time backups of EBS volume. They can be used for disaster recovery, data migration, volume resizing, and for creating consistent backups of production workloads. EBS snapshots are incremental, so they only save the blocks on the volume that have changed after your most recent snapshot. EBS snapshots can be used to create multiple new volumes volumes, and new volumes created from a snapshot are an exact copy of the original volume at the time the snapshot was taken. Snapshots of EBS volumes are stored redundantly in multiple availability zones using Amazon S3. If we talk about benefits, EBS volume supports data portability through their ability to detach and reattach to instances as needed. There are many practical reasons you might choose to do this, like data migration, instance type changes, disaster recovery, cost optimization, and performance tuning. That's pretty much about block storage. Let's discuss about object storage. Now, if EBS is a hard drive, Amazon S3 is an infinite warehouse. You don't attach it to the computer, you just toss files into buckets via the internet. S3 is the GOAT because of durability. AWS basically promises if you store 10,000 objects, you might lose one every 10 million years. That's 11 nines of durability. Amazon S3 is a fully managed, highly available storage service for storing and retrieving any amount of data as objects. It offers 99.99% durability, meaning your data is protected against loss, and offers features like versioning, lifecycle management, and various storage classes to optimize cost. Amazon S3 stores files as objects in containers known as buckets, and each object can range in size from a few bytes to several terabytes. It integrates seamlessly with other AWS services and supports a wide range of use cases, from basic backups to complex data lakes. Amazon S3 offers various storage classes to suit a variety of workloads with specific performance, access, resilience, and cost requirements. They are also designed to address data residency requirements, unpredictable access patterns, archival storage needs, and offer the most cost-effective options for different access patterns, like S3 Standard. S3 Standard is considered general-purpose storage for cloud applications, dynamic websites, content distribution, mobile and gaming applications, and big data analytics. When you upload an object to Amazon S3 without specifying a storage class, the object is added to S3 Standard by default. Next one is S3 Intelligent Tiering. This tier is useful if your data has unknown or changing access patterns. S3 Intelligent Tiering stores objects in 3 tiers: a frequent access tier, an infrequent access tier, and an archive instance access tier. Amazon S3 monitors access patterns of your data and automatically moves your data to the most cost-effective storage based on the frequency of access. Next one is S3 Standard Infrequent Access. This is for data that is accessed less frequently but requires rapid access when needed. S3 Standard IA offers the high durability, high throughput, and low latency of S3 Standard with a low per GB storage price and per GB retrieval fee. This storage tier is ideal if you want to store long-term backups, disaster recovery files, and so on. Next one is S3 One Zone Infrequent Access. This stores data in a single availability zone, reducing cost compared to S3 Standard IA, which uses 3 zones. This storage class suits customers seeking affordability storage for infrequently accessed data without high availability needs. It's perfect for storing secondary backups or easily recreatable data. Next one is S3 Access One Zone. It stores data in a single availability zone. It was purpose-built to deliver consistent single-digit millisecond data for your most frequently accessed data and latency-sensitive applications. S3 Express One Zone delivers data access speed up to 10 times faster and request cost up to 80% lower than the S3 Standard. Next one is S3 Glacier Instant Retrieval. Use this for archiving data that is rarely accessed and requires millisecond retrieval. Data stored in this storage class offers a cost saving of up to 68% compared to the SA Standard IA storage class with the same latency and throughput performance. Next one is S3 Glacier Flexible Retrieval. It offers low-cost storage for archive data that is accessed 1 to 2 times per year. With S3 Glacier Flexible Retrieval, your data can be accessed in as little as 1 to 5 minutes using an expedited retrieval. You can also request bulk retrievals in up to 5 to 12 hours at no additional cost. It's an ideal solution for backup, disaster recovery, off-site data storage needs, and for when some data occasionally must be retrieved in minutes. Next one is S3 Deep Glacier Archive. It is the lowest cost S3 storage class. It supports long-term retention and digital prevention for data that might be accessed once or twice per year. Data stored in the S3 Glacier Deep Archive storage class has a default retrieval of up to 12 hours. It is designed for customers that retain data sets for 7 to 10 years or longer to meet the regulatory compliance requirement. Examples include those in highly regulated industries such as financial services, healthcare, and public sectors. Last one is Amazon S3 Outpost. It delivers object storage to your on-premise using Amazon S3 APIs and features and serves workload with local data residency requirements. It also helps maintain optimal performance when data must remain in close proximity to on-premise applications. There's another important concept linked to S3, that is S3 lifecycle. It is used to avoid manually managing your object storage tiers configurations. You can use S3 lifecycle configuration to automate the process. When you define a lifecycle configuration for an object or group of objects, you can choose to automate between two types of actions: transition actions or expiration actions. Transition actions define when objects should transition to another storage class, and expiration action defines when objects expire and should be permanently deleted. For example, you might transition objects to S3 standard IA storage class 30 days after you create them, or you might archive objects to the S3 Glacier Deep Archive storage class 1 year after creating them. But if you have 10 different servers and they all need to see the exact same spreadsheet at the same time, block storage can do that. You need file storage. File storage consists of two services, Amazon EFS and Amazon FSX. Amazon EFS is a shared folder of Linux. It grows and shrinks automatically. You don't have to manage anything. It just works. Amazon EFS is fully managed, scalable file storage service for the use with AWS Cloud Services and on-premise resources. It operates using the Linux Network File System Protocol and automatically scales to petabytes as you add or remove files without disrupting applications. EFS is designed to support a wide variety of workloads and can be accessed by multiple EC2 instances simultaneously. Amazon EFS benefits include multiple easy redundancy, shared access, and elastic storage. Now next up is Amazon FSX. This is for the specialty stuff. Need a Windows specific file server? Use FSX. Doing heavy duty machine learning? Use FSX for Lustre. Amazon FSX makes it convenient and cost effective to launch, run, and scale feature rich high performance file system in the cloud. It supports a wide range of workloads with its reliability, security, scalability, and broad set of capabilities. Compared to Amazon EFS, which focuses on the network file system compatibility, Amazon FSX support multiple file system protocols including Windows File Server, Lustre, OpenZFS, and NetApp ONTAP. Amazon FSX is built on the latest AWS Compute, networking, and disk technologies to provide high performance and lower total cost of ownership. As a fully managed service, it handles hardware provisioning, patching, and backups. Amazon FSX benefit includes file system integration, managed infrastructure, scalable storage, and cost effectiveness. Last thing before we wrap up, some of you might still have servers sitting in a physical office. For these in-betweeners, AWS offers two services: Storage Gateway and Elastic Disaster Recovery. Storage Gateway, this is a bridge. It lets your office servers pretend they are saving files locally, but in reality, they are sending them straight to the AWS cloud. Storage Gateway is a hybrid cloud storage service that make it possible to seamlessly integrate on-premise environments with AWS cloud storage. You can use it to extend your local storage to the cloud while maintaining low latency access to frequently used data. You can use Storage Gateway to streamline storage management and reduce costs for practical hybrid cloud storage use cases. These include moving backups to the cloud, using on-premise file shares backed by cloud storage, and provisioning low latency access to data in AWS for on-premise applications. Benefits include seamless integration, improved data management, local caching, and cost optimization. Storage Gateway offers three distinct types of gateways to meet hybrid storage needs. These are Amazon S3 File Gateway, Volume Gateway, and Tape Gateway. Amazon S3 File Gateway bridges your local environment with Amazon S3. It provides on-premise applications with access to virtually unlimited storage through familiar file protocols. S3 File Gateway makes it possible to store and retrieve cloud objects using familiar file operations. With Volume Gateway, you create virtual storage volumes while maintaining local access to your data. It essentially works as a bridge between your on-premise infrastructure and AWS cloud storage by presenting your cloud data as volumes that can be mounted by your existing applications. Tape Gateway makes it possible to replace physical tape infrastructure with virtual tape capabilities while benefiting from the durability and scalability of AWS Cloud Storage. Tape Gateway provides an interface that works with existing tape backup software, making the transition from physical tapes to cloud storage seamless. Next up is Elastic Disaster Recovery. This is your break glass in case of emergency tool. It constantly mirrors your servers to AWS, so if your building gets hit by a literal lightning bolt, you can click a button and be back online in minutes. Elastic Disaster Recovery replicates critical workloads to AWS with minimal downtime. Your server's block level data is continuously replicated to AWS, making it ideal for uses that require robust disaster recovery solutions. It supports both physical and virtual servers to enable rapid recovery during disruptions, which is particularly valuable for industries like healthcare, where system availability is crucial. You can use Elastic Disaster Recovery to reduce downtimes and data loss while eliminating the cost associated with maintaining secondary data centers. It also offers non-disruptive disaster recovery testing, meaning it's capable of quickly launching recovery instances when needed. With that said, we had covered Module 6 as well. So here's the quick gist. There are three types of storages: block storage, object storage, and file storage. If you need a fast hard drive for one server, use EBS. If you need to store billion photos forever, use S3. If you need a shared folder for a whole team, use EFS. Storage is not scary once you know the why behind the what. Smash that like button if this cleared things up. Hey everyone, welcome to Module 7. Today we're gonna talk all about databases. A database is an organized electronic collection of structured information or data, typically stored and accessed within a computer system. Managed by a DBMS, it allows users to efficiently store, retrieve, manage, and update data using language like SQL. Main type of databases are relational databases and non-relational databases, which is also known as NoSQL databases. Relational databases stores data in tables with rows and columns, while NoSQL databases store data in various formats like documents, graphs, or key value pairs. AWS offers fully managed relational database solutions that remove the burden of database administration while maintaining high availability and security. AWS relational databases support popular database engines like MySQL, PostgreSQL, and Oracle, making it easier to migrate existing databases to AWS, like Amazon Relational Database Service and Amazon Aurora. Amazon RDS is a managed relational database service that handles routine database tasks such as backups, patching, and hardware provisioning. Amazon RDS supports multiple database instance class types that optimize for memory, performance, or input outputs. To improve data resilience, Amazon RDS offers multi-AZ deployment and automated backups, but you can also manually create backups using DB snapshots. These are full backups of your entire database instance, which can be useful for specific points in time recovery or long-term data archiving. Amazon RDS offers security features including network isolation, encryption in transit, and encryption at rest. You can readily scale database resources vertically or horizontally as needed. Amazon RDS supports different database engines including Amazon Aurora, SQL, Postgres, MariaDB, and Oracle DB. Benefits include cost optimization, multi-availability zone deployment, performance optimization, and security controls. Then we have Amazon Aurora. Amazon Aurora is a managed relational database designed to help reduce unnecessary input-output operations. It's compatible with MySQL and PostgreSQL, provides high performance and availability, and automatically scales along your workloads. Aurora replicates data across multiple availability zones for enhanced durability and fault tolerance, and provide features like automated backup, encryption at rest, and continuous monitoring. The benefits include high performance and availability, automated storage and backup management, and advanced replication and fault tolerance. Now, if we talk about NoSQL databases, they are sometimes referred to as non-relational databases because their structures are different than relational databases like Amazon RDS. Instead of row and column relations, NoSQL databases build a structure for the data that they contain using key value pairs instead. With key value pairs, data is organized into items identified by unique keys. For NoSQL databases, AWS offers Amazon DynamoDB. DynamoDB is a fully managed NoSQL database service that provides fast and predictable performance for both document and key value data structures. It's a powerful and incredibly fast database option for use cases that require a flexible schema and is ideal for applications that require high performance and seamless scaling. DynamoDB seamlessly scales alongside your data without impacting performance, which means that you only pay for the resources that you use. It also includes built-in security features for enhanced protection and automatically spreads your data across multiple servers to handle your workloads. Benefits include scalability with provision capacity, consistent high performance, high availability and durability, and data encryption. Now, using relational and non-relational databases, we had stored data, but normally getting data from a disk takes time. For example, if 1000 people are asking for the same top 10 list, we can't make the database work for it 1000 times. We're gonna catch it once and serve it up instantly. This is where AWS introduced Amazon Elastic Cache. Elastic Cache is a fully managed in-memory caching service that was built to help reduce the complexity of administrating in-memory caching systems. Benefits of Elastic Cache includes high performance for Redis, Valkey or Memcached instances, high availability, replication across multiple AZs, and data encryption. There are few additional database services offered by AWS like Amazon DocumentDB, AWS Backup, and AWS Neptune. DocumentDB is a fully managed service designed to handle semi-structured data, which is information that doesn't conform to rigid relational schemas. DocumentDB is a MongoDB compatible database, so it manages JSON-like documents with dynamic schemas. DocumentDB is perfect for applications requiring frequent schema changes and document-oriented data. Unlike relational databases or non-relational databases, you can quickly iterate without relying on predefined schemas. DocumentDB can store, query, and index JSON data effortlessly, all while benefiting from automatic scaling, continuous backup, and enterprise-grade security features. Benefits include MongoDB compatibility, performance and scalability, and increased read throughput. Next up is AWS Backup. Backup streamlines data protection across various AWS resources and on-premise deployments by providing a single dashboard for monitoring and managing backups. It eliminates the complexity of managing multiple backup strategies by supporting multiple storage types, including Amazon Elastic Block Store volumes, Amazon Elastic File Systems, and various databases. Backup centralizes and automates data protection processes, improving consistency and reducing administrative overhead. It offers flexibility, scheduling options, encryption capabilities, and cross-region backup support for enhanced disaster recovery. Benefits include centralized backup management, cross-region backup redundancy, streamlined regulatory compliance, and lastly, we will be talking about AWS Neptune. Neptune is a fully managed, purpose-built graph database service that manages highly connected datasets. Like those used in social networking applications, it excels at understanding complex relationships that are difficult to identify in traditional relational databases like user connections, friend networks, and interaction patterns. Neptune can maintain high performance even as data complexity grows and offers high availability with automatic failover and backups. Benefits include it is purpose-built for complex relations and it offers high performance and scalability. That's a wrap on Module 7. Databases don't have to be intimidating, they are just different ways of remembering what matters to your users. Let's begin with Module 8. We have all seen how AI is basically the engine under the hood for modern businesses. Take Amazon for instance. ML models are doing everything from guessing what you will want to buy next for fulfillment centers. But it's not just for retail. We are seeing ML predict stock market shift, route your customer service calls so that you are not on hold forever, and even spot a fraudulent bank transaction before the money leaves your account. Now, if you are looking at the AWS AI ML stack, think of it like a three-story building. The first floor, it's the AI services. These are the plug and play. They are predefined and ready to go. Think Amazon Poly for turning text into speech, or Comprehend for reading the vibe and sentiment of a document. The second floor is of ML services. This is for when you need something custom but don't want to manage the hardware. This is where Amazon SageMaker AI lives. You can build, train, and deploy your own models in one spot. It even handles the detective work like debugging and monitoring. The third floor is the frameworks and infrastructure. This is for the experts who want to build from scratch. We are talking custom chips and optimized EC2 instances, basically the raw power for specialized needs. Let's zoom in on that first floor. Those pre-built AI services. They are basically experts you can hire via APIs. If you are working with language, you have got Comprehend. It's dig into documents to find insights or check for compliance. Amazon Comprehend uses natural language processing to extract key insights from documents. It develops these insights by recognizing key phrases, language, sentiment, and other common elements in documents. Use case includes content classification, customer sentiment analysis, and compliance monitoring. Next one is Poly. She or he turns text into lifelike speech in dozens of accents. Amazon Poly converts text into lifelike speech. It supports multiple languages, different genders, and variety of accents. Use case includes virtual assistants, e-learning applications, and accessibility enhancement for visually impaired users. Next one is Transcribe. Go-to for turning speech to text, perfect for subtitling or logging customer calls. Amazon Transcribe converts speech into text. It supports multiple languages and offers features such as speaker identification, customer vocabulary, and real-time transcription. Use cases include customer call transcription, automated subtitling, and metadata generation for media content. Next one is Translate. Translate does exactly what it says the tin in real time. Amazon Translate is a text translation service. This service is ideal for global communication because it supports real-time batch text translation across multiple languages. Use case includes document translation and multi-language application integrations. Then there's vision and search. For that, we have services like Amazon Kendra. Forget keyword searching. Kendra actually understands what you are asking. It's like a librarian for your company's data. Amazon Kendra uses natural language processing to search for answers within large amount of enterprise content. Because it understands the context of a query, it can return more precise and relevant answers than just a list of documents with matching keywords. Use cases includes intelligent search, chatbots, and application search integrations. Next is recognition. It sees the things in photos and videos, identifying objects, people, or even flagging inappropriate content. Amazon Recognition is a video analysis service. It can identify objects, people, text, scenes, and activities within images and videos stored in Amazon S3. Use cases includes content modernization, identity verification, media analysis, and home automation experiences. Next one is Text Track. This is a lifesaver for paperwork. It reads handwriting and tables so you don't have to manually type them in. Amazon Text Track detects and extracts typed and handwritten text found in documents, forms, and even tables within documents. Use case include financial, healthcare, and government form text extraction for quick processing. And for personalization, we have services like Amazon Lex, tech behind Alexa. Use it to build chatbots that actually feel like they are listening. With Amazon Lex, you can add voice and text conversational interfaces to your applications. This service uses both natural language understanding and automatic speech recognition to create lifelike conversations. Use cases include virtual assistants, natural language search for FAQs, and automated application bots. Next one is Amazon Personalize. It's your you might also like engine using your data to predict what customers want. With Amazon Personalize, you can use historical data to build intelligent applications with personalized recommendation for your customers. Use case includes personalized streaming, product, and trending recommendation. Now let's talk about the buzzword of the century, generative AI. To understand it, you have to look at deep learning. These are models that mimic the human brain using neural networks. It's a math, but it acts like neurons. This is what lets us tackle the really hard stuff like creating brand new content. Generative AI is powered by foundation models. These are the giants of the AI world. It's like old models that could only do one thing. These can be adapted for a million different tasks. On AWS, you have got three big ways to play with this: SageMaker Jumpstart, Amazon Bedrock, and Amazon Q. SageMaker Jumpstart is like a hub where you can grab a foundation model and fine-tune it with your own data in few clips. SageMaker Jumpstart is a machine learning hub within SageMaker AI that accelerates the process of building, training, and deploying ML models. SageMaker Jumpstart offers a library of pre-built ML solutions across various domains such as computer vision, NLP, and tabular data. These pre-trained models can be fine-tuned to suit your specific needs and deployed with just a few clicks. Next one is Amazon Bedrock. This is the easiest way to build. It gives you a choice of models from Amazon and companies like Anthropic all through one API. Amazon Bedrock is a fully managed service that was specifically designed for working with large foundation models and building generative AI applications. It provides access to foundation models from Amazon and leading AI startups such as Cloud and Stable Diffusion all through a single unified API. With Amazon Bedrock, you can quickly experiment with foundational models, fine-tune them with your own data, and seamlessly integrate them into your AWS applications. Next one is Amazon Q. This is your new AI assistant. Q Business answers questions based on your company private data, and Q Developer actually helps you write code. Amazon Q is a generative AI assistant that can help companies streamline processes, get to decision faster, and improve employee productivity. It can help every employee gain insights into their data and accelerate their task. None of this AI magic works without data, right? Think of the data like a fuel, but raw data is usually a mess. Before the AI can eat, we have to go through ETL. We grab data from everywhere, clean it up so it's stable, park it to a data lake or a data warehouse like Amazon Redshift. To make this happen on repeat, we make data pipelines with ingestion, cataloging, and processing. Ingestion is getting data in. You can use Kinesis for real-time streaming like stock prices or Firehose to dump data straight into storage. If we talk about Amazon Kinesis data streams, you can use this Kinesis data stream for real-time ingestion of terabytes of data from applications, streams, and sensors. This serverless service even provides automatic provisioning and scaling in on-demand mode. And Amazon Data Firehose is an option for data ingestion in near real time. It is fully managed service, provides automatic provisioning and scaling. It also delivers data within seconds to data lakes, data warehouses, and analytic services. Next up is cataloging. You need to know what you have, right? AWS Glue acts like a catalog for your data, keeping track of all the metadata. For that, we have AWS Glue Data Catalog. It provides a centralized, scalable, and managed metadata repository that enhances data discovery. It improves the overall efficiency of data pipelines by delivering metadata to various data stores and analytics services. Next up is processing. Cleaning the data. Glue is great for visual and code-free cleaning. If you have massive complex code, Amazon EMR is the heavy lifter. If we talk about Amazon Glue, Glue is a fully managed ETL service that makes data preparation simpler, faster, and cost-effective. Glue jobs can use AWS Glue Data Catalog, which we just discussed, to access metadata about data sources, which can help inform transformations defined in the ETL scripts. Next up is Amazon EMR. EMR is ideal for large-scale data processing and organizations with exiting big data expertise. It automatically handles infrastructure provisioning, cluster management, and scaling. Amazon EMR supports popular big data frameworks like Apache Spark, Apache Hadoop, and Apache Hive. Once data pipelines are ready, your team can query it using Athena, which is serverless and super fast, or visualize it in QuickSight, to build those fancy dashboards. If we talk about Athena, with Athena you can run SQL queries to analyze data in relational, non-relational, object and custom data sources. This is fully managed serverless service that can access data hosted on Amazon S3, on-premise, or even in multi-cloud environments. It offers a cost-effective solution for data analysis because you only pay for the queries you actually run. Next one is Amazon QuickSight. With QuickSight, both technical and non-technical users can quickly create modern interactive dashboards and reports from various data sources without managing infrastructure. Amazon Q in QuickSights provide natural language queries so business analysts and user can build, discover and share meaningful insights in seconds. Next up is Amazon Redshift. Redshift is a fully managed data warehouse solution. Its columnar storage and massively parallel processing architecture make it ideal for analyzing large data sets. You can use it to perform complex SQL queries on large datasets for frequent, high-performance analytical workloads. If you need real-time search or log monitoring, OpenSearch service is your best friend. With Amazon OpenSearch service, you can search for relevant content through precise keyword matching or natural language queries. Unified dashboards provide real-time data visualization as you analyze and monitor logs, traces, and metrics for various applications. Essentially, you can ingest data once into an S3 data lake and then your marketing team can use it for BI while your science team uses it to train a brand new ML model. That's not just tech, that's working smarter. And that's the tip of the iceberg for the AWS data journey. Welcome to Module 9. Before diving into the tech, we have to distinguish between two terms that people often mix up: authentication and authorization. Authentication, this is all about identity. For example, an employee entering a username and password to log into a company portal. Authentication is the process of verifying the identity of a user or entity through credentials like a username and password combination. Next up is authorization. This is all about permissions. For example, once logged in, that same employee can view their own payroll data but is blocked from seeing everyone's else. Authorization grants user certain access rights and permissions that determine which actions they can perform in a system or application. Now, as we are clear on authorization and authentication, let's also touch base on AWS shared responsibility model for security. Security on AWS is not just their job or your job, it's a partnership. We break this down into two categories: security of the cloud and security in the cloud. If we talk about security of the cloud, AWS handles the heavy lifting. They protect the physical data centers, the hardware, the cables, and the virtualization layer that runs the services. If a hard drive fails or a data center needs a physical security guard, that's on AWS. AWS is responsible for security of the cloud. AWS operates, manages, and controls the components at all layers of infrastructure. This includes securing the foundational software that powers AWS, the virtualization layer, and the hardware and global infrastructure that supports the data centers from which service operates. This includes protection from regions, availability zones, and edge locations as well. Next up is security in the cloud. You are responsible for everything you put in the platform. This includes your data, how you configure your operating system, your network settings, and most importantly, who you give access to. When using AWS services, customers maintain complete control over their content. As a result, customers are responsible for securing everything they create and manage in the AWS cloud. This includes managing the security of data, systems, and applications, deciding what data and workloads to store or run in AWS, determining which AWS services to use, and controlling who has access to environments and resources. One of the best way to prevent security incidents before they happen is through proper permission and access management. That's where IAM comes into picture. IAM is the control tower for security. It starts with the root user created when you first open an account. This user has absolute power. With IAM, by default, all actions are denied. You must explicitly grant permissions to someone before they can perform any actions in your account. When you grant permissions, you should provide access only on a need to have basis. This concept is called principle of least privilege. Now, as we just discussed that we firstly open AWS account, we get root user. So surely we need to understand the best practices for this root user. That includes change the password to something complex, enable multi-factor authentication immediately, stop using it for daily tasks, create IAM users with limited power. As our root user is now secure, episode, let's come back on how IAM works. IAM provides users, groups, and roles so you can configure access based on your company's specific operational and security needs. IAM policies define the needed access for these identities. It consists of users, groups, roles, and policies. IAM users represent a person or application that interacts with AWS services and resources. It consists of a name and credentials. AWS recommends creating individual IAM users for each person who needs to access the AWS account, so they have their own unique set of security credentials. IAM group is a collection of IAM users. When you assign permissions to a group, all users in the group inherit the permissions. For example, you might assign standard access permissions to a group called employees, so all your employees receive the same generic access. IAM role is an identity you can assume to gain temporary access to permissions. For example, an employee might need to work as a barista in the morning and a cashier in the afternoon. When someone assumes an IAM role, they abandon all previous permissions they had under a previous role and assume the permissions of the new role. An IAM policy is a JSON document that allows or denies permissions to access AWS resources and services. IAM policies can also define the level of access to resources. They follow the principle of least privilege, meaning you give a user the bare minimum access they need to do their job and nothing more. For example, you can allow employees to access all the Amazon S3 buckets in your AWS account or only a specific bucket. Now, as we know what's IAM, let's understand protecting networks and applications. Network and application protection is another vital component of a secure environment on AWS. You might have heard of DOS and DDos attacks. Let's quickly go through them. In a denial of service attack, an attacker floods a web application with excessive network traffic. Legitimate customers' requests are denied if a web application becomes overloaded and can no longer respond. While in distributed denial of service attack, an attacker can use multiple infected computers or zombie bots to unknowingly send excessive traffic to a web application. AWS automatically protects against low-level brute force attacks such as DDoS through its built-in infrastructure and network architecture. AWS infrastructure reaches across the globe and include multiple regions, availability zones, and edge locations. It is designed to make it difficult for attackers to overwhelm the system. Let's review some of the ways for application protection. That includes security groups, AWS Shields, and AWS WAF. Security group is something which we had already covered. You can go and watch that video. Just to give you a gist, it acts as a built-in firewall. If the traffic is not explicitly allowed, it never reaches your instance. AWS Shield automatically enabled for everyone at no cost. It stops the most common brute force network attacks. It is having two versions, AWS Shield Standard and AWS Shield Advanced. Standard is designed to automatically protect AWS customers from the most common frequently occurring type of DDoS attacks at no cost. It uses a variety of analysis techniques to detect and mitigate incoming malicious network traffic in real time. AWS Shield Advanced is a paid service that provides detailed attack diagnostics and the ability to detect and mitigate sophisticated DDoS attacks. It also integrates with other services such as Amazon CloudFront, Amazon Route 53, and ELB. Third one is AWS WAF, also known as Web Application Firewall. It lets you block specific IP addresses or patterns like SQL injections at the application level. Amazon WAF is a web application firewall that monitors network requests that come into your web applications. When a request comes into AWS WAF, it checks the IP address against a web access control list. If the request comes from a blocked IP address on the web ACL, AWS WAF denies. As you already know, to keep data private, we use encryption, which turns readable data into a secret code that requires a key to unlock. Data encryption comes in two forms, that is encryption in transit and encryption at rest. Encryption in transit protects the data while it's moving across the internet. We use TLS certificates managed by Amazon Certificate Managers. Encryption at rest protects data sitting on a disk like an S3 or a database. AWS Key Managed Service handles the creation and management of these kind of digital keys. AWS offers few data protection services to help protect your data like AWS Key Management Service, AWS Mackie, and AWS Certificate Manager. You can use AWS Key Managed Service to create and manage cryptographic keys. These keys can then be used to encrypt and decrypt your data. You can also control the use of keys across a wide range of services and in your applications. For example, you can specify which IAM users and roles can manage keys. Your keys never leave AWS KMS, and you can temporarily disable them so that they can no longer be used. Next up is Mackie. With Amazon Mackie, you can monitor your sensitive data at rest to make sure it's safe. Mackie uses machine learning and automation to discover sensitive data stored in Amazon S3. You can use Mackie to access your security posture, which is especially helpful for meeting compliance requirements. Last up is AWS Certificate Manager. ACM centralizes the management of your SSL or TLS certificates that provides data encryption in transit. It can be used to protect various AWS services and your connected on-premises resources. Preventing and protecting against security threats are two methods for securing your AWS resources. You should also be prepared to detect and respond to security incidents that might occur. AWS offers a variety of services that you can use to detect and respond to security incidents such as Amazon Inspector, Amazon Guard Duty, Amazon Detective, and Amazon Security Hub. Amazon Inspector helps improve the security and compliance of applications by running automated security assessments for Amazon EC2 instances, containers, and Lambda functions. It checks applications for security vulnerabilities and deviations from security best practices such as open access to EC2 instances and installations of vulnerable software versions. You can view completed assessments in Amazon Inspector console. These assessments include a list of security findings prioritized by several levels. Each identified security issue includes a detailed description and a recommendation for how to fix it. You can also retrieve these findings through an API. Next up is Amazon Guard Duty. It provides intelligent threat detection across your infrastructure and resources. Guard Duty identifies threats by continuously monitoring streams of your account metadata and network activity in your environment. It uses non-malicious IP addresses, anomaly detection, and machine learning to identify threats more accurately. You can review detailed findings about any Guard Duty detected threats in the AWS Management Console. Findings include recommended steps for remediation. You can also configure AWS Lambda functions to perform remediation steps automatically. Next up is Amazon Detective. After a threat has been detected, you can use Amazon Detective to further investigate the root cause. Detective helps you analyze threats with interactive visualizations contained in a unified Amazon Management Console view. These visualizations include resources and user interactions over a configurable timeline with recommended steps for remediation. Last one is Security Hub. Security Hub brings multiple security services together into a single place and format. With this service, you can quickly use your security and compliance statement in one comprehensive view. Security Hub automatically aggregates security findings from AWS and partner services and organizes them into actionable, meaningful groupings called insights. It can accelerate time to resolutions with automated remediation. Security in AWS is layered. You start by identifying users using IAM, protecting the parameters using Shield or WAF, locking down the data using KMS or ACM, and constantly watching for threats using Guard Duty or Security Hub. With that said, we had covered module 9 as well. If you ever felt like your AWS environment is growing faster than you can keep track of, you are not alone. Managing a handful of resources is easy. Managing hundreds or thousands is where things get tricky. Today we are diving into the control center of AWS. We will cover how to optimize your cost, automate your security, and keep your entire cloud compliant without losing your mind. We have divided this module 10 into 5 sections. Those are monitoring and auditing, compliance, governance, health checks, and advisory. Let's jump in and understand the importance of monitoring. Monitoring your cloud resources is important. It provides a way for you to continuously observe and analyze system activity, network traffic, and security events to detect potential threats or anomalies. Monitoring is a critical component for ensuring the security, availability, reliability, and performance of your cloud-based workloads and data. Monitoring is performed using real-time monitoring tools, log collection and analysis, and dashboards. There are two very popular monitoring and auditing services provided provided by AWS, that are CloudWatch and CloudTrial. CloudWatch is about performance. It tells you how much CPU am I using, is my application healthy. It's your dashboard of metrics and alarms. CloudWatch monitors your AWS resources and the applications that you run on AWS in real time. With CloudWatch, you gain system-wide visibility into resource utilization, application performance, and operational health. CloudWatch does more than just monitor. It has several features that work together, like CloudWatch metrics, CloudWatch alarms, CloudWatch dashboards, and CloudWatch logs. If we talk about benefits, CloudWatch helps you visualize and analyze your resources, operate efficiently with automation, use an integrated view, proactively monitor, and gain insights. If we talk about use cases, it can be used to monitor and troubleshoot infrastructure. CloudTrial, on the other hand, is about activity. It's the audit log. It answers who deleted the database at 2 a.m. It tracks every API call made in your account. CloudTrial tracks users' activity and API usage in the AWS Cloud on-premise and even with other cloud providers. CloudTrial provides a detailed history of API calls so you can track changes and identify who made them and when. This helps you understand what actions were taken on your AWS resources. If we talk about benefits, CloudTrial provides auditing, security monitoring, and operational troubleshooting. It also helps you prove compliance and improve your security posture. If we talk about use cases, it can be used for compliance and auditing, identifying security incidents, and troubleshooting operational issues. After we are done with monitoring and auditing, we need to think about compliance as well. Compliance refers to your cloud resources and data adhering to relevant regulations, industry standards, and internal policies regarding security and data protection. AWS helps you meet compliance goals and requirements by inheriting the latest security controls that AWS uses on its own infrastructure, third-party validation for thousands of global requirements, streamlining and automating compliance, and on-demand compliance report. For compliance report, we have AWS Artifacts. Artifacts is a service that provides no-cost on-demand access to AWS security and compliance report and select online agreements. If I talk about benefits, AWS Artifacts help you manage at scale, save time with on-demand access to compliance report, and deploy with more confidence. If I talk about use cases, it can be used to manage select online agreements and access third-party security and compliance. AWS Artifacts consist of two types: artifacts agreements and artifact reports. In artifact agreements, you can review, accept, and manage agreements for an individual account and for all your accounts in AWS organizations. Different type of agreements are offered to address the needs of customers who are subject to specific requirements such as health insurance, portability, and accountability act. Artifact reports provide compliance reports from third-party auditors. These auditors have tested and verified that AWS is compliant with a variety of global, regional, and industry-specific security standards and regulations. AWS Artifacts reports remain up to date with the latest reports released. You can provide the AWS audit artifacts to your auditors or regulators as evidence of AWS security controls. Now let's talk about auditing AWS resources for compliance. For that, we have AWS Configs and AWS Audit Manager. Config is a service that you can use to access, audit, and evaluate the configurations of your AWS resources. If we talk about benefits, Config helps evaluate configurations against the desired state, manage resources configuration changes, and simplify troubleshooting and remediation. If I talk about use cases, it can be used to continually audit security monitoring and analysis and to streamline operational troubleshooting and change management. Audit Manager is a service that continually audits your AWS usage to simplify risk and compliance assessment. It helps collect evidence and manage audit data. If I talk about benefits, Audit Manager saves time with automated evidence collection, streamlines collaboration across teams, and helps ensure integrity of audits with read-only permissions. If I talk about use cases, it can be used to automate evidence collection, continually audit to access compliance, and deploy internal risk assessments. As your company grows, you will move to a multi-account strategy. AWS Organizations let you manage billing and security policies centrally. Organizations help you centrally manage and govern your environment as you grow and scale your AWS resources. It helps you manage policies for group of accounts and automate account creation. If we talk about benefits, organizations provide several benefits like quickly scaling your environment by programmatically creating new AWS accounts for resources and teams. It also helps by simplifying permission management through SCPs and managing and optimizing cost across your AWS accounts and resources. If I talk about use cases, it can be used for automating AWS account creation, providing tools and access for your security teams, controlling user access to designated services, and sharing common resources across accounts. We are done with monitoring, auditing, compliance. Let's also have a look on governance. AWS offers 3 services that can help govern and enforce services and accounts to meet your company's requirement. Those are AWS Control Tower, AWS Service Catalog, and AWS License Manager. If you want to set up an entire multi-account environment with guardrails already in place, use AWS Control Tower. It's the automated factory that builds a secure landing zone for your teams to work in. Control Tower is a service you can use to enforce and manage governance rules for security, operations, and compliance at scale across all your organizations and accounts in AWS Cloud. If we talk about benefits, Control Tower can help you save time while providing governance. It uses pre-configured controls which can help you quickly set up multi-account environments, automation with built-in governance, and integration of third-party softwares at scale. If we talk about use cases, use AWS Control Tower to quickly deploy applications and provision compliant AWS accounts. Now let's move on to AWS Service Catalog. To keep things organized, AWS Service Catalog lets your developers buy pre-approved IT services from a curated menu. It keeps them fast and keeps you in control. With Service Catalog, you can create, share, and organize from a curated catalog of AWS resources. You can deploy baseline networking resources and security tools for new AWS accounts so you can govern consistently. If I talk about benefits, Service Catalog saves time by making it quick to find and deploy approved self-service cloud resources. It also helps you stay agile while improving governance over resources across multiple accounts. If I talk about use cases, use it to provision resources across AWS accounts, apply access controls, and accelerate provisioning of continuous integration and continuous delivery pipelines. And for those of you bringing your own licenses from Microsoft or Oracle, AWS License Manager tracks those for you so you don't accidentally break your vendor agreements and face a heavy fine. License Manager is a service that helps you manage your software licenses and fine-tune your licensing cost. If we talk about benefits, License Manager helps with visibility and control, tracking and managing licenses, and reducing the risk of non-compliance with licenses. If I talk about use cases, use it to streamline License Manager and to simplify Microsoft license mobility through software assurance experience. You can also use it to automate the distribution and activation of software entitlements across AWS accounts for end users. We are done with governance as well. Let's talk about health checkup in AWS. For that, AWS offers health dashboards. If something does go wrong with AWS itself, check with AWS Health dashboards. It's not just a journal status page, it's account specific. If there's a scheduled maintenance on your specific EC2 instance, this is where you will see it. It gives you the heads up you need to stay ahead of downtime. With AWS Health dashboards, you can view account specific health information and get AWS Health event updates. You can also use AWS Health programmatically using the AWS Health API, which is available with AWS Premium support. If I talk about benefits, AWS Health dashboard provides valuable information as a data source for events and changes. It gives you timely and actionable guidance to remedy issues. It also helps manage service health and is integrated and automated to use at scale. If I talk about use cases, use health dashboards to view account specific health information. You can also use it to plan for life cycle events or troubleshoot an incident. Let's now talk about AWS Trusted Advisor. Think of this as your personal cloud consultant that never sleeps. It constantly scanning your environment against 5 core pillars. Those are cost, performance, security, fault tolerance, and service limits. If you are on a basic plan, you get dozens of essential checks like spotting an MFA-less root account. But if you are on a business or enterprise support, you unlock hundreds of checks. It's the difference between having a map and having a GPS that tells you exactly where the traffic jams are. Use it to kill zombie resources and save money on day one. Optimizing large-scale cloud deployments is extremely important to do, and it's not a one-time thing. You must look for ways to optimize for cost, performance, security, and resilience. With AWS Trusted Advisor, you can continuously evaluate your AWS environment by using best practice checks across several categories. All AWS support plans include access to dozens of Trusted Advisor checks. With business support and other advanced plans, you can benefit from hundreds of checks. If we talk about about benefits, Trusted Advisor helps you align with AWS best practices, prioritize recommendations, and optimize your AWS resources at scale. If I talk about use cases, it can be used to optimize cost, efficiency, security, improve performance, and track service limits. Lastly, let's talk security. IAM Access Analyzer is your best friend for reaching least privilege. It analyzes your policies to see who actually has access to your resources from the outside world. It does not just find errors, it helps you refine permissions so you only give people exactly what they need to do their jobs, no more, no less. IAM Access Analyzer provides capability to set, verify, and refine permissions by analyzing external access and validating that your policies match your corporate security standards. If we talk about benefits, IAM Access Analyzer provides benefits like refining permissions, validating IAM policies, helping you meet your least privilege goals, and automating IAM policy reviews. If we talk about use cases, it can be used to set fine-grained permissions, verify who can access what, remediate unused access, and refine and remove broad accesses. And that is your tour of AWS governance and monitoring. We have covered everything from saving money with Trusted Advisor to staying legal with artifacts. Remember, the cloud is powerful, but only if you have the reins. If you found this helpful, hit that subscribe button. The cloud is powerful, but what if you don't understand the bill? It can feel like a bit of mystery. If you have ever worried about overspending or wondered how to get the best bang for your bucks on AWS, this video is for you. Today we are breaking down the fundamental pillars of AWS pricing, the tools that help you manage it, and how to leverage the AWS marketplace and partner network to scale faster. First, let's talk about how you actually pay. There are three core concepts that keep AWS flexible and cost effective: pay as you go, save when you commit, and pay less by using more. If we talk about pay as you go, this is a classic cloud advantage. You only pay for what you use. It allows you to adapt to changing business needs instantly, so you never have to worry about the risk of over provisioning or worst, running out of capacity. If you know you are going to be using certain services like Amazon EC2 for a long haul, you can opt for savings plan. By committing to a 1 or 3 year term, you can see massive discounts compared to standard on-demand prices. If we talk about pay less by using more, AWS Reward Scale. For many services, pricing is tiered. This means as your data grows and your usage increases, your per unit cost actually goes down. Now, what actually shows up on the invoice? While every service is different, there are three fundamental drivers of cost. Those are compute, storage, and outbound data transfer. The exact price will shift depending on the service type, your specific configurations, and the AWS region you choose. Now let's talk about AWS pricing and billing services. AWS provides a suite of purpose-built tools to help you track and manage these costs, like AWS Organizations. Think of this as your command center. It's perfect for centralized management. You can group accounts, apply security policies across the board, and most importantly, consolidate your billing into a single payment method. AWS Organization provides centralized management and governance of your AWS environment. Using AWS Organizations, you can create, group, and manage accounts. You can also apply security policies at the account level and consolidate billing with multiple accounts using a single payment method. If we talk about use cases, it is a perfect pick to consolidate multiple AWS accounts into one central organization, and it is also a good one to implement organization-wide policies. Next up is billing and cost management dashboards. This is your daily health check. It gives you visualizations of your monthly spend, helps you manage payment methods, and shows you exactly where your money is going. The AWS billing and cost management dashboard centralizes cost management, showing current charges, usage forecast, and detailed breakdowns. It also provides tools to manage payments, view invoices, set budgets, and consolidate billings. If we talk about use cases, it is useful for visualization and billing reports of monthly AWS spends, and you can use to set up and manage your payment methods. Next up is AWS budgets. This is your early warning system. You can set custom thresholds and get alerts before you overspend. If your projected costs look like they are going to exceed your budget, you will be the first to know. AWS budgets help set custom budgets and send alerts when cost, usage, or saving plans and reserved instances utilization or coverage exceed defined thresholds. If we talk about use cases, it can be very useful in setting up alerts for when projected costs exceed predefined thresholds, and it is a good use case for forecast future expenses based on the current usage trends. Next up is AWS Cost Explorer. For the data lovers, this is where you dive deep. It uses interactive graphs to analyze historical spendings and even gives you recommendations for saving plans. AWS Cost Explorer helps visualize, analyze, and manage AWS cost and usage with interactive graphs, reports, and forecasts. It provides insights into spending patterns, trends, and reserved instances recommendations. If we talk about use cases, it is a good fit to analyze historical spending trends to identify cost saving opportunities, and it is a good fit for forecast future AWS cost based on current usage patterns to budget effectively. Next up is AWS Pricing Calculator. Use Pricing Calculator if you are still in the planning phase. You can input your instances type and storage needs to get a detailed estimate before you ever click launch. AWS Pricing Calculator is a web-based planning tool that you can use to create estimates. You input specific configurations such as instance types, storage options, and data transfer volumes. Then based on your configurations, you receive a detailed cost breakdown to help you budget for your AWS resources allocation. If we talk about use cases, it is a good fit when you have to estimate potential cost before deployment, and it is a good service to compare cost of different AWS services and configurations. Finally, you don't have to build everything from scratch. You have AWS Marketplace. It's a digital catalog with thousands of software listings. Whether you need a SaaS tool for project management, pre-built machine learning models, or data analytics platforms, you can find, test, and buy them right there. It even has industry-specific solutions like healthcare compliant models for patient record protection. AWS Marketplace is a digital catalog that includes thousands of software listings from independent software vendors. You can use AWS Marketplace to find, test, and buy software that runs on AWS. For each listing in AWS Marketplace, you can access detailed information on pricing options and reviews from other AWS customers. But what if you need a human touch? That's where the AWS Partner Network comes in. These are global experts who use AWS to build specialized solutions for you. And if you are a builder, consider becoming an AWS partner yourself. You will get access to funding benefits, exclusive training, and networking events to help you scale your own business alongside AWS. The AWS Partner Network is a global community that uses AWS technologies, programs, expertise, and tools to build solutions and services for customers. Together, partners and AWS provide innovative solutions, solve technical challenges, and deliver customer value. You can work with AWS partners to create or use specialized solutions that are tailored to your unique business needs. Understanding AWS pricing is not just about saving money, it's about gaining the confidence to innovate without limits. Use these tools, monitor your drivers, and don't be afraid to lean on the marketplace and partner network. So you got your brand new AWS account. The new car smell is great, right? But for most of us, we are not starting from scratch. We are likely got servers running in your own basements, a data center, or maybe you have already started a journey with another provider. If you are feeling like you are stuck between two worlds, don't worry. Moving to the cloud is not a flip of a switch. It's a journey, and today I am going to walk you through the roadmap AWS uses to make sure that journey does not end in a breakdown. AWS helps guide companies through the migration process, which can be divided into three sequential phases. These are assess, mobilize, migrate, and modernize. If we talk about assess, this is your look before you leap phase. It identifies your goals and build the business case. Basically, you are answering the question, why are we doing this and what do we gain? In this phase, you build the business case for the migration and assess your readiness. One of the services used in this phase is Migration Evaluator. Migration Evaluator is a migration assessment service that helps you create a business case for AWS cloud planning and migration. It does this with a data-driven approach, analyzing your current state, target state, and developing a migration readiness plan with the projected cloud cost. If we talk about benefits, the benefits include removing the guesswork when migrating. It provides visibility into multiple cost-effective cloud migration scenarios. It also gives insights on reusing existing software licensing, which can further reduce cost. If we talk about use case, you can use Migration Evaluator to conduct broad-based discovery, take a snapshot of your current on-premise footprint to fine-tune licensing, view server dependencies, and gain visibility into multiple migration scenarios. You can also use it to estimate and reduce your cloud cost. Next up is Mobilize. Now we are packing the bag. We look at how your apps talk to each other, the interdependencies. You can't move the heart without the lungs, right? We fix the gaps in your plan here. In this phase, you prepare the organization and mobilize the resources needed for the migration. Two services you might use in this phase are AWS Application Discovery Service and AWS Migration Hub. AWS Application Discovery Service discovers on-premise server inventory and connections. It gathers configurations, performance, and connection details for both servers and databases to create a detailed migration plan. If we talk about benefits with Application Discovery Service, you get a comprehensive snapshot of your on-premise inventory. You also can integrate discovery data with the other services like Migration Hub and protect the data Application Discovery Service collects. If we talk about use cases, you can use the Application Discovery Service to conduct discovery and inventory, map the connections and dependencies, and generate a migration plan. Next up is Migration Hub. The Migration Hub is a centralized hub to take you from discovery, assessment, planning, and execution of your migration. It provides tools, guidance, and automated recommendations to collaborate with your team and track your migration. If we talk about benefits with the Migration Hub, you have one location to go for your migration and expert guidance in the form of perspective journey templates. Another benefit is cost saving because there is no charge to use Migration Hub. If we talk about use cases, you can use Migration Hub for migration, assessment, and planning, and migration completion and collaboration with teams. You can also use it for modernization efforts like fast tracking application refactoring. Lastly, Migrate and Modernize. This is moving day. We move the apps, validate them, and maybe even give them a facelift to run better in their new home. In this phase, you use your strategy, plan, and the best practices to migrate and modernize. Tools to support you include AWS Application Migration Service, AWS Data Migration Service, and AWS SCT. AWS Migration Service is a tool to move and improve your own premises and cloud-based applications. It helps customers streamline, expedite, and reduce the cost of migrating and modernizing applications. The benefits include support to migrate from any source infrastructure that runs a supported operating systems. It makes it possible to modernize your applications during migration. You can maintain normal business operations during the application replication process and also reduce cost by using one tool for a wide range of applications. If we talk about use cases, you can use the Application Migration Service for on-premise applications running on physical servers or infrastructure, cloud-based application, or moving between AWS regions. You can also use it to modernize applications. Next up is AWS Data Migration Service. It makes it possible to quickly and securely migrate databases and perform ongoing data replication tasks for live databases and data warehouses. It provides a way to plan, assess, convert, and migrate databases even with the data warehouse in one central tool. AWS DMS provide benefits for migrating databases, including maintaining high availability and low downtime during the migration process. It supports homogeneous and heterogeneous migrations. It also makes it possible to migrate terabyte-sized databases at a low cost. If we talk about use cases, you can use AWS DMS to move to managed databases, remove licensing costs, replicate ongoing changes in your database, and improve integration with the data lake. Next up is AWS SCT. SCT makes it possible to convert database schemas and code objects like stored procedures, views, and functions from one database engine to another. AWS SCT can even give you estimates of how big of an effort a conversion is, which helps with planning. SCT provides benefits to simplify database migrations by automating schema analysis, recommendations, and conversions at scale. It is compatible with popular databases and analytics service as source and target engines. It can save weeks or months of manual time and resources which are typically required in conversions. If we talk about use cases, you can use SCT to move from commercial databases to open source databases. You can also use it for migrating large data warehouse workloads and modernizing or updating database schemas in place. Now, if that sounds like a lot to juggle, you are right. It is. That's why we use AWS CAF, the Cloud Adoption Framework. It's not just about the tech, it's about the whole business. We look at it through 6 different lenses. On the business side, we focus on strategy and people, and on the technical side, we focus on governance, platform, security, and operations. By checking all 6 boxes, you reduce the risk of a successful migration that actually breaks your company culture or your budget. Let's discuss about 7 migration strategies. When it comes to actually moving an app, you have 7 options. We call these the 7 R's. These are rehost, relocate, replatform, refactor, repurchase, retain, and retire. Let's fly through them. Rehost is also known as lift and shift. You just copy paste your server into the cloud. It's fast and it can save you up to 30% in cost immediately. Rehosting is also known as lift and shift. It involves moving applications without changes. In the scenario of a large legacy migration in which a company is looking to implement its migration and scale quickly to meet a business scale, the majority of applications are rehosted. Next up is relocate. If you are already using VMware or containers, you just move the hosting location. Easy. Relocating is changing the hosting location to a cloud. This could be if applications are already virtual machines or containers running on premises and then moving to the cloud. Next up is replatform. Lift, tinker, and shift. You move the app, but maybe you swap your old databases for something like Amazon RDS. You are not changing the core code, just giving it better tires. Replatforming, also known as lift, tinker, and shift, involves moving a few cloud optimizations to realize a tangible benefit. Optimization is achieved without changing the core architecture of the application. Next up is refactor. You are rewriting code to take full advantage of the cloud. High effort but the highest reward. Refactoring, also known as re-architecting, involves reimagining how an application is architected and developed by using features built for the cloud. Refactoring is given by a strong business need to add features, scale, or improve performance that would otherwise be difficult to achieve in the application's existing environment. Next up is repurchase. It's like drop and shop. You ditch your old licensed software and buy a cloud-native SaaS version instead. Repurchasing involves moving from a traditional license to a software as a service model. For example, a business might choose to implement the repurchasing strategy by migrating from a customer relationship management system to a new Salesforce software. Next up is retain. Sometimes the best move is no move. If the app is retiring in 6 months, let it stay where it is. Retaining consists of keeping applications that are critical for the business in the source environment. This might include applications that require major refactoring before they can be migrated or work that can be postponed until a later time. Last one is retire. In the big companies, about 10% of IT is zombie softwares no one uses. Turn off the lights and save the money. Retiring is the process of removing applications that are no longer needed. Finally, how do you get petabytes of data in cloud? If you have a good internet connection, use AWS Data Sync for speed or AWS Transfer Family if you need to use old school protocols like FTP. If you need a private highway, use AWS Direct Connect. Data Sync is specifically designed for automating and accelerating data transfer. Data Sync simplifies and accelerates moving large amount of data between on-premise storage and AWS storage services like Amazon S3. It automates many aspects of the transfer process, including running instances, encryption, and network optimizations. The benefits include streamlining and accelerating secure data migrations. Data Sync manages data movement workloads with bandwidth throttling, migration scheduling, task filtering, and task reporting. It also provides rapid data replication. If we talk about use cases, you can use Data Sync to migrate your data, archive your cold data, and manage hybrid data workflows. The AWS Transfer Family makes it possible to seamlessly manage and share data with simple, secure, scalable file transfers. This service provides fully managed support for secure file transfer over FTP, secure file transfer protocol, secure, and other protocols. It helps you transfer files directly into and out of AWS storage services like Amazon S3 and Amazon EFS. The benefits include simplifying the process of setting up and managing file transfers and reducing the need for complex infrastructure management. The Transfer Family provides secure data transfer with encryption and authentication to ensure data integrity and confidentiality. It is built to scale and streamline workflows. If we talk about use cases, you can use the transfer family to modernize and manage your file transfers, simplify data sharing with your workforce and partners, and integrate transactional business data into a unified data lake. AWS Direct Connect is a service that makes it possible for you to establish a dedicated private connection between your network and virtual private cloud in the AWS Cloud. Because it is your dedicated connection, it is fast, reliable, and secure way to transfer your data or file. If we talk about benefits, direct connects help reduce network cost and increases the amount of benefits. But what if your internet is slow or non-existent? Then we go old school with a futuristic twist, that is AWS Snowball Edge. A Snowball Edge devices are a great solution for offline data migration where connecting to the internet might not be an option. These devices deliver high performance NVMe storage, making it possible to simplify multi-petabyte data migrations from on-premise locations to AWS. The benefits include delivering better compute performance and larger storage capacity with gigabytes of data per second for data migration workloads with offline requirements. If we talk about use cases, you can use Snowball Edge devices for data migration when offline migration is required. They can also be used for edge computing when a secure, rugged device is needed. With that said, we had covered module 12 as well. When you first look at the AWS console, it can feel like you are starting at a 1000-piece logo set. It's overwhelming, but here's the secret. AWS does not expect you to use everything. Most services are purpose-built. Today we are looking at the specialist, the services designed for specific jobs like building apps, running a business, or even managing smart pet feeders. Let's break these down into 4 categories: development services, business application services, end user computing services, and IoT services. First up, development. If you are a coder, you want to spend your time writing code, not babysitting servers. Think of AWS Code Build and AWS Code Pipeline as your automated factory. Code Build is a worker. It compiles your code and runs the test, while Code Pipeline is the conveyor belt. It moves your code from written to live without you having to lift a finger. This is what we call CI/CD, and it's the heartbeat of the modern software. Code Build is a fully managed continuous integration service that compiles source code, run tests, and produces software packages for deployments. It automatically scales to meet demands, and you only pay for the build time that you use. While Code Pipeline is the fully managed CI/CD service that automates the build, test, and deploy phases of your release process. This helps developers streamline software release workflows and reliably deliver new features and fixes without needing to provision servers. But what happens when things break? That's where AWS X-Ray comes in. It's like a doctor's X-ray for your code. It shows you exactly where the bottleneck is so you can fix it before your users even notice. X-Ray is a powerful tracing, debugging, and performance analysis tool that helps developers visualize application behavior. With X-Ray, developers can quickly identify performance bottlenecks, troubleshoot issues, and optimize applications for better efficiency and reliability. And for the front-end fans, we have AppSync and Amplify. AppSync uses global QL, which is basically a way for your app to say, hey, I only want these 3 pieces of data. Don't send me the whole library. And Amplify is your all-in-one starter kit. It lets you add things like login screens and storage in minutes, not days. AppSync is a fully managed GraphQL service. With AppSync, developers can create a single GraphQL API that can securely access, manipulate, and combine data from multiple data sources. This helps developers connect front-end applications with back-end data. Amplify helps you streamline the process of developing, deploying, and managing secure and scalable full-stack applications on AWS. With Amplify, developers can quickly add features like authentication, API, storage, and hosting with minimal infrastructure management. Now let's pivot to the business side. If you have ever called a support line and it felt smooth and smart, they were probably using Amazon Connect. It's an AI-powered contact center, no hardware, just a browser and a headset. Businesses can use this AI-powered contact center service to efficiently set up and operate scalable customer service call centers. Amazon Connect provides capabilities to call routing, recording, and analytics while integrating seamlessly with other AWS services. And if you need to send a million emails without getting marked as spam, AWS Simple Email email service is your best friend. It's built for high volume, reliable delivery. AWS SCS is a scalable and cost-effective email service provider that can be integrated into any application for reliable, high volume email automation. It helps businesses optimize the delivery of transactional and marketing emails, resulting in enhanced customer engagement. Now let's talk about end user computing services, which is our third category. In this world of remote work, we have Amazon Workspaces and AppStream 2.0. Workspaces is the desktop in the cloud. Your employee can log in from a 10-year-old computer and still have the high performance Windows or Linux desktop ready to use. Workspaces is a fully managed cloud-based desktop computing service. With Workspaces, employee can securely access their work environment from any device with an internet connection. Employees can perform the same task as if they were on physical office computer, while companies can benefit from cost efficiency and easy administration. AppStream is slightly different. It just streams the app. If you need to run a heavy 3D design program on a cheap Chromebook, AppStream makes it happen. AppStream is a fully managed service that streams applications from the cloud directly to any compatible device. This includes software as a service applications and applications converted from desktop to SaaS without code revisions. This provides instant access to powerful software without the need for high-end local hardware. Let's get a bit sci-fi and talk about the Internet of Things, or IoT. This is the network of physical stuff, smart cameras, pet feeders, irrigation systems. They all need to talk to each other securely. AWS IoT Core is a grand central station for these devices. It handles the billions of messages they send, keeps the connection encrypted, and makes sure your smart pet feeders don't accidentally trigger your home security alarm. AWS IoT Core is a managed cloud service used to securely connect physical devices with cloud applications. It helps you create efficient IoT solutions by streamlining the complex process of ingesting, processing, and acting on device data. Device connections and data are secured with mutual authentication and end-to-end encryption, and you can choose from several communication protocols. Some IoT solutions include smart security cameras for home monitoring that sends alerts to your phone, smart pet feeders, a pet feeder that you can control remotely, and smart irrigation systems, a rain machine that adjusts watering based on weather and soil conditions. Now listen carefully. This is the part you need to know by heart for your exam and your career. It's the AWS well-architected framework. Think of this as the architect's Bible. It's built on 6 pillars: operational excellence, security, reliability, performance efficiency, cost optimization, and sustainability. If we talk about operational excellence, this is about continuous improvement. If you can automate a task, do it. Operational excellence focus on operations, monitoring, automation, and continuous improvement. Next up is security. This is the guard dog pillar. Lock the doors, use the principle of least privilege, and protect the data. Security protects systems and data through best practices like least privilege and data integrity. Next up is reliability. This is your safety net. Can your system survive a crash? We designed for failure so your users never feel it. Reliability emphasizes recovery planning and system adaptability to meet changing demands. Next up is performance efficiency. Don't use a sledgehammer to crack a nut. Right size your resources so they are efficient. Performance efficiency encourages using the right resources for the job and adjusting as needs evolve. Next up is cost optimization. Stop wasting money if you are not using a server. Turn it off quickly. AWS gives you the tools to find those money leaks. Cost optimization helps control and reduce cost through smart provisioning and resource management. Lastly, we have sustainability, the green pillar. This is also known as the green pillar. We want to minimize our environmental footprint by using only the energy we actually need. Sustainability promotes energy efficient design and environmentally conscious resource usage. We might be thinking, how do I need to track all the 6 pillars? Well, AWS literally gave us the well-architected tool. It's free. It's like a self-service checkup. You answer a few questions about your project and it splits out a report. It tells you, hey, you are doing great on security, but you are spending too much money here. It even gives you the remediation steps, the how to on fixing it. Totally customizable. So if a question does not apply to you, just toggle it off. No stress. The AWS well-architected tool is a free service that helps assess and improve cloud workloads based on the 6 key pillars: operational excellence, security, reliability, performance efficiency, cost optimization, and sustainability. It offers workload reviews, milestone tracking, and custom lenses for tailored evaluations and improvement plans. Integrated with AWS services like AWS IAM and APIs, it supports team collaboration and continuous progress tracking. The AWS well-architected tool is ideal for architects, engineers, and compliance teams, and it promotes consistent, actionable, and well-documented architecture reviews. Whether you are building the new viral app with Amplify or securing a massive enterprise with well-architected tool, AWS has a specialist for that. The cloud is not just about servers, it's about building things better. If this helped you clear the fog, hit that subscribe button. Congratulations for completing all the AWS CCP topics. This is a great achievement. Thank you so much for watching along. Have a nice day.